Good evening. Good evening. Are we live? Yes, I guess we are live. I can see myself. I'm sorry for that technical glitch. Yes, good evening, my dear J Warriors. So I hope I'm clearly visible and audible. Let me just access that comment screen properly. So, yes. Yes, good evening, everybody. Good evening. Good evening, Sachin Pathak. So, good evening, beta. I hope everybody is doing great and everybody is ready for the electrochemistry part 2. Although it is written electrochemistry, but yes, all the students who are joining, let me just first greet everybody. So, Sachin, and we have Arun Krishna. So, hello, beta. Jay. Jay Stole Roast. Good evening, my dear. Then we have, do you know about Xylem learning? Arey Arun Krishna, if you are from Kerala, then I have been to your institute for a week. And yes, I've conducted those class 11 classes and I enjoyed it. Yes, the only issue is the travel, but beta, I love the place. I love you people. If you're from there, then I still remember those lunches that we had and the dinner, yeah, especially. I mean, leaving everything, the food over there is awesome. So yes, I do remember it, beta. So, chalo, everybody, Arjuna student. Okay, Krishna is Arjuna student. So Arjuna J. Arjuna J from Kerala. Okay, beta. So obviously, very good to see you, Priyanshu Kumar. Good evening. I'm your big fan, Sachin. Either beta teachers exist because of you. So if we can help you, obviously life is worth and your future, your JEE will also be worthwhile to excel in your professional career after that. है ना? Chalo. Sir, do you take chemistry thermodynamics? Beta, as of now, all the best faculties take all the paid classes of Arjuna J in English, Lux J in English. Yes. So do not worry because PW is beta system. The system works for the betterment of the student, whoever is there in the batch. है ना? Chalo. So sir, let us continue with the topic that we intend to start and finish on in the same session. So this is a one shot for electrochemistry. Yes, we have done the JEE mains part of electrochemistry, but yes, today we would be rather discussing good topics. So the topic for today is, sir, electrochemical cells, the basic, so the Nernst equation, concentration cell, the thermodynamics equilibrium. These topics we have already covered, where we have covered in electrochemistry part 1. Let me just, everybody who has just joined and do not know that thing, so let me just go to that YT page and let me just introduce that topic to you. The first live that we had for electrochemistry. So what you have to do is go to PWJ. I need to just, yes, you get muted and you will get that video where first go to PWJ English. Once you are there in PWJ English, not on me, but PWJ English, then go to the live section. Under the live section, you will be having these beautiful videos, which is definitely helping them, helping you, helping every JEE aspirant like anything. Over there, we had electrochemistry part 1 here. This is done, I guess, 1 month back. I'm very sorry that I'm bringing the second part a bit late because yes, before in between we had loads of session and students, and in my Laksh batch I've already started with organic, and hence those students were actually focusing, sir, do the one shot for organic first. So be it, we have to do that for them also, and hence we had came live also with the organic discussion. This is electrochemistry part 1. 3 hour 16 minute video. There we have discussed these. Now today we intend to finish the complete electrochemistry, and today we will be starting with Types of electrodes, sir, the temperature coefficient of the cell, because sir, as you change the temperature, sir, the potential of the electrochemical cell also changes. How? We will do that. Then we will do, sir, qualitative and quantitative analysis. Once you pass electricity, the same cell becomes electrolytic cell. So what is produced is qualitative analysis, and how much is produced is the quantitative analysis, where we study the Faraday's law. So we will do both these analysis, and we will end the session with the discussion of conductance of those electrolytic cell, because for the metallic conductors you do the calculations in physics, but sir, when ions conduct, that is electrolytic conductance. It is governed by basic principles and then Kohlrash's law, and we will end with those titration curves. The conductance curve also signify that what you have for a weak, whether you have strong acid getting titrated with weak base or whatever. So those conductometric titrations, those graphs are very important for JEE Mains also, although advanced started asking it, but now Mains ask it like anything. So this is the task for today. We'll be very precise, very relaxed. But yes, sir. Sir, let us revise at least few questions from Nernst equation, because obviously in your JEE Mains also, advanced also, sir, first one question for Nernst equation is always there. And hence, let us start with the revision of the previous part. But yes, we'll be very quick, just 2 questions. We will try to revise the Nernst equation application. So giving you 1 minute just to read the question. It is an integer type question. So quick, everybody. We are beginning the class with a question, and that is what a JEE aspirant should do. So by the time, let me just read those comments. Arun, welcome. Now attempt these questions, beta. Sachin, sir, please say something for my motivation. Sachin, you are going to be awesome, and only your hard work is going to make that true, real. So you are awesome, and you have to work in order to show people also that you are awesome. That's it. Single liner. Anna. Deepankar Patra. So hello multiple times, Deepankar. Hello multiple times, Deepankar. Chalo, everybody. I hope everybody is attempting. Chalo. So sir, let me just check how many of you have actually attempted the previous live. If you have, the answer is definitely there with you. I just want to see the percentage. Cool. Everybody is here, beta. Chalo. So answer for the question, I guess, it's 1818. So let me see how many of you. Nah, chalo. So let us revise. That means, sir, we need a proper revision. So let us revise quickly. Sir, the hydrogen electrode is dipped. Okay, sir. It is dipped where? It is dipped in a solution which is having pH of 3. Sir, if pH is 3, that means H plus ion concentration is 10 raised to the power minus 3. Why? Because sir, pH is minus of log of H plus ion concentration. Log means to the base 10. Okay, sir. Then we have to give the electrode potential. Acha, sir, that means it's a gas anion electrode. So sir, if you have a bucket, in that bucket you have water. Sir, water is not a conductor of electricity, but in order to make it conducting, I've added ions. How much H plus ions I've added? The concentration I know. But sir, in order to make an electrode, obviously I will use a inert metal. What is that inert metal? If you are having no problem of money, then use platinum. If you have problem, use graphite, because more or less graphite is also inert, more or less, although it reacts. So we take a platinum metal because that's a inert metal. It just provides its surface for the conduction of electrons. And yes, in order to increase the rate of reaction, we increase the surface area. How we increase the surface area? We coat this with crushed platinum. So that is called a activated platinum. So that the surface area gets increased, and now we pass the gas. What gas we want this to be act as? What electrode we want to this electrode? What gas? Whatever gas you pass, this electrode will absorb that gas in itself, and this complete electrode will behave as that gaseous electrode. So hydrogen gas I am passing, and H plus ions are there over here. Sir, technically on under standard condition, the pressure of hydrogen gas that you use is 1 bar. Okay, master. So the question is asking us the electrode potential, the potential of electrode. And sir, if the question is asking us the potential of electrode, then electrode potential as per IUPAC convention represents the reduction potential. So we have to give the reduction potential. Sir, what does reduction mean? Sir, gain of electron. So what half of reaction you will write? Sir, H plus ions will gain electron and will form a hydrogen gas. Sir, ions will be there in the solution. Okay, beta. Now, in order to balance this, let me use 2 over here, 2 over here. So now it's a balanced reaction, and for this balanced reaction, I will write the Nernst equation, which says electrode potential, which is the reduction potential, is equal to standard electrode potential. Sir, but standard electrode potential as per the electrochemical series, what reference electrode we choose? Hydrogen. So this standard potential is what, master? This is 0 minus RT upon NF, but if I make ln as log, then it becomes 2.303 RT upon NF. The complete multiplier becomes 0.059 upon number of electron transferred. Now, how many electrons are transferred? So 2 electrons are transferred. So upon 2 into log of. Log of what? Sir, reaction quotient Q of this, sir. This can be, sir, every reaction is a equilibrium reaction, sir. So reaction quotient Q is concentration of product upon reactant. Yes, sir, because I have gas, so sir, gas also will disturb equilibrium. But what is the pressure of the gas? Sir, pressure of the gas is standard 1 bar, and question has not changed it. Yes. Under standard condition, concentration is 1 molar, but we have not created that standard condition. Hence, we are calculating whatever is your electrode potential. So product will be 1, but reactant will be H plus ion concentration, which is 10 raised to the power minus 3. But sir, stoichiometrically, you have to square this value. Okay. Acha. Let me not put the value first, because I hope if you have attended the previous class, but because it has been 1 month, so let me do this properly. So this is H plus ion concentration square. Sir, it will go to the numerator, so it will become minus 2. So sir, that minus and minus will become plus, and this 2 and that power will be getting cancelled. That means, sir, electrode potential, which is the reduction potential, will be equal to positive of 0.059. So that 2 is gone, but this will be log of H plus ion concentration, because this 2 and this 2 also have cancelled. Sir, pH is minus of log of H plus ion concentration. So log of H plus ion concentration will be negative of pH. So this will be negative of pH. So that means it will be negative of 0.059 into the value of pH. Acha, sir, then shall we remember this? Yes, you should. So this is your reduction potential of what? Of hydrogen electrode. Sir, what will be its oxidation potential? Positive of this value. Now, because in the question it is asking us the magnitude, or maybe it has just written the potential of electrode. It has not mentioned what electrode it is, and sir, answer has to be positive. So let us report oxidation potential, because the reduction potential is negative and answer it is saying it is positive. So let us write the oxidation potential. Sir, if reduction potential is this much, then oxidation potential will be plus of 0.059 into the value of pH. Value of pH is 3, and let's say it is approximately 6, because anyhow we have to do 10 raised to power minus thing. So let us say 0.06 approximately into 3. That will make us 18. So 6 into 3 is 18. and because I have two decimals, so this will be 0.18 approximately, because you have to do that integer approximation. So why bother writing 0.059? So that means master answer is 18. Yes. Sir, but if this is a JEE mains question, that's why you should remember such conclusions. What conclusions? Sir, for hydrogen electrode, reduction potential is negative of 0.059 pH and oxidation potential is positive. I hope everybody is clear. Guys. Ravindra Singh. हैं? उस दिन आप बात कर रहे थे, आपने मुझसे बात नहीं की. नहीं बेटा, I guess you are having peer-to-peer doubt solving, Mr. Singh. Because if you are talking of me, then I am not that person. Ajay, chalo, I hope everybody is clear. Please read a little faster. Hai? Acha, that means peer-to-peer doubt solving is happening. Chalo, I hope everybody is clear. Patra is asking, Kansa class? Konsa class, I hope you mean. That means, beta, we are discussing class 12th electrochemistry. Chalo, shall we continue? Great. Now, sir, one more question. But yes, you have to do that calculation by yourself. Try to solve, bachon, everybody. Integer type question, again, JEE mains question. Now, by watching these questions, you can definitely have this idea, beta. Master, even JEE mains asking is asking good quality of electrochemistry questions, and yes, definitely you should not attempt these questions in the first go. First do those easy and moderate questions, and obviously in order to create that edge, because most of the students will be doing it, so to be that 99 percentiler beta, you have to master electrochemistry. है ना? Chalo. Everybody, quick, at least read the question, because 50% of the question is solved once you read the question properly. So reading the question. Sir, I am preparing for JEE and board. Good for you, beta. A perfect ideology that you're following. Great. Now, everybody, please at least read the question properly. Chalo. Done. Let us do it together. I'll check later. Sir, consider the following reaction. Okay, beta, this is a redox reaction that we have to consider. Sir, where manganese, which is present in X minus 8 equals minus 1, that means plus 7 oxidation state, is getting reduced to plus 2 oxidation state. So charge transfer is of 5 electrons. And sir, this guy, carbon, sir, so what is its oxidation state? Plus 2 plus 2x minus 8 equals 0. That means 2x is equal to 6 rupees. That means x is plus 3. And here obviously, sir, this is easy. Carbon is in plus 4 oxidation state. So from plus 3 to plus 4, how much electron is getting transferred? Master, only 1. But sir, this complete species having 2 carbons, so both of the carbon will be doing it. That means, sir, it is 2. But sir, this guy is asking for 5 and this guy is offering 2. Sir, how the transaction will be completed? You do not have to balance the reaction, because we just need to calculate the total electron transfer. So just do this common sense of oxidation number method. Master, how the charge transfer will become equal? Multiply this by 5 and multiply this by 2. You do not have to completely balance the reaction, because why bother? If we only need the charge transfer, we already have the charge transfer with us. Okay, sir. That means, sir, total electron transfer will be 10. That means this is the value of number of electron transferred. You do not have to balance even the reaction, if at all you do not require. Now let us read the question. Now you have to find the standard reduction. Acha, nahi, nahi. The standard reduction potential of two halves are given, and you have to give me the equilibrium constant value K in the form of this. Okay, sir. Then, sir, again write Nernst equation, because we know cell potential will be equal to standard cell potential plus RT upon NF into ln of Q. But sir, it is asking about the equilibrium concentration. So that means at equilibrium, sir, at equilibrium, rate of forward reaction will be equal to rate of backward reaction, sir. No useful work, sir. Delta G will be 0, hence cell will stop to function. And sir, Q will be equal to K. Acha, master. That means this is 0. So, sir, I can directly, yes, I'm just doing it again. So, to make you revise things, but you can directly do this, sir. What? Beta, that means E naught cell is directly equal to minus RT, sir. Put the value, na, because that will go that side. So, minus 0.059 upon n, so number of electron transferred is 10 into ln will become log, so log of equilibrium constant K. That's why you do not have to write the balanced reaction, because you do not need that stoichiometry. Done. Now the question is just asking us this value of K, and the only variable we are left with this E naught. And sir, what is E naught cell? E naught cell is E naught of cathode minus E naught of anode. So sir, who is cathode? The person who is getting reduced. So E naught cell master will be equal to E naught of cathode. Sir, who is cathode? The person getting oxidized. That means MnO4 minus turning to Mn plus 2 minus standard electrode potential of the species who is getting oxidized, acting as anode. Sir, this H2C2O4 is acting as anode, but sir, we have to write its reduction potential. So reduction potential will be this getting this, that means CO2 forming H2 C2O4. Acha, master, value are given. So for manganese, the value given is 1.51. And for this guy, the value given is minus of 0.49. Sir, it is easy also. This is directly 2 rupees, sir. So 2 volt. E naught cell is 2 volt. Array, master, we know E naught cell. So therefore, I can use this value and I can say log of K master will be equal to 2 into this 10 upon, it will be minus, sir, 0.06. Let us do this approximation. So this will be, sir, 2000 upon 6 rupees with a negative sign. But, sir, I want this answer. Acha, this is log K, na? It is given as 10 raised to the power x. Acha, 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 acha. One thing, I am sorry. Beta, E cell is equal to E naught cell minus RT upon NF. I'm sorry. So this will be plus RT upon NF. I'm sorry. So this will be plus. That means this is plus. So the answer is 2000 upon 6. So your answer is 2000. But sir, why you are saying 2000 upon 6? Because K will be equal to 10 raised to the power 2000 upon 6. And you are supposed to give me the value of X. So X will be 2000 upon 6. So 6 3 ja 18. Then you have 2 over here. So 6 3 is again 18. Then again, so 3 3 3. Let us check. 339. This should be 2000 upon 6, na? So 18. 333. So answer will be 333. Everybody, please check. Where 2 into 10. Acha, that 10 also I have used. Yes, so 20 upon. Acha, beta, because this is integer type, so do not do this approximation. Because see, if you have approximated, it is asking you the exact value. So because it is asking us the exact value, so here doing approximation will kill my answer. So technically, do 0.059. That means, master, this is 0.059. So this is 20 upon 0.059. So it will be, sir, 20 into 30, sir, upon do exact 59. Now let us, beta, you don't use calculator. Yes, I am using calculator because yes, you do this calculation properly because beta, yes, this is what JEE asks you to do. You have to be very, very comfortable, very, very quick with your calculations. So this will be 338.9 beta. This will be 338.9. So integer you will mention as 338 as in 339. So answer is 339. Good one. Yes, mathematically challenging, but I hope everybody's clear. Guys, Akash is asking, sir, do we watch the video or lecture in PW to understand this chapter due to backlogs? Akash, technically, if you are already Laksh JEE student, then I would definitely suggest you should. One shots are always good, great for revision beta. If you're trying to learn the chapter, yes. If you have already enrolled, then go for the recordings and then revise from here. Else, if you have not yet enrolled, the link is already there in the video, so you can join. So nahi, I have loads of this and that already there, so obviously better, then this will definitely be serving you. But you have to revise multiple times beta. Yes, instead of making many questions from various books, attempt a single book, a single module, because everybody has that level of questions these days. But yes, make sure it's having appropriate number of questions, appropriate amount of questions, and then everything is your practice beta. The more you do, the more you excel. है ना? New batch JEE key. Okay, sir. Thank you, sir. Okay, beta. Chalo. Let's move forward then. Now moving to, this is how we have revised whatever we have more or less completed in the previous session. Now let us bring new things. Acha. Sir, let us discuss the types of electrode. So the first type of electrode, beta, acha, I'm sorry, I have not checked your answer. So this is 339 for the previous case. Chalo. Acha. Let us move forward. Sir, the types of electrode. So beta, the first type of electrode that we have already discussed is a metal and a metal ion electrode. So whenever you have a metal, then in order to do the redox, you will use some salt of that metal. So that will be a metal ion electrode, the simple electrode that we use. Yes. What else we have already seen? Sir, gaseous electrodes. What are gaseous electrodes, sir? There are some elements who do not exist as solid at room temperature. Then how the hell we will make them do the electron transactions? Use inert platinum and adsorb whatever element you want to adsorb who is not present in solid state, because inert metals will just create that environment where the electron transfer will be offered by them and they will not participate chemically because they are inert. Sir, now, the third electrode that you should know, obviously, we have used this gaseous electrode, metal ion, and we'll see these electrodes again. Acha. Now, the next electrode that I want to everybody to remember is calomel electrode. Not very famous, but yes, for advance, for good questions, you should definitely know what a calomel electrode is. So everybody, do anybody know what calomel electrode is? Just hit the comment section with that. Anybody knows what calomel electrode is? Just hit the comment section with that. What element we are talking of? Sir, Dipankar is crying. In board, I joined Xylem. There are so many backlog, and Arjuna JEE also. How could manage this? Tell me. Beta, Arun, man, everybody has got 24 hours, beta. Everybody has got 24 hours. So management is a thing which, if you start working on a day now, analyze whatever you have done. Now try to manage the same thing, try to be efficient, at least whatever you have done today, whatever amount of things you have done today, try to manage the same efficiency next day. That's it. In order to do that regularly, do not be a hero on a day. As in, sir, I'm studying 13, 14 hours a day, not sleeping. Take care of your biological system, so your body clock, sleep properly. I'm not saying sleep for 8 hours. Yes, maybe sleep for 4 hours in a stretch, 5 hours, then take a nap, power nap of 1 hour. So total 6 hours of sleep, but distributed in 2 sessions will make you fresh. At least do half an hour of some physical workout, maybe walk or something. Play, but yes, physically play, no video. And then beta study whatever rest time you have, study. So this is the best management. First follow that, and then your discipline will tell you what to do. Then second thing is, sir, start with 2 chapters per week. So 2 subjects per week, if it is being not unmanageable, and then proportionally switch the 2 chapters, 2 subjects in the next week. Let's say this week focus on chemistry and physics, then physics, maths. I mean, for some students it works, but beta, you have to do that hit and trial thing, because there are many students who manage everything. So, but yes, there may be some X, there may be some Y in your system that is a variable. So you have to identify that variable by yourself. I know. Chalo. But yes, the only thing you need to maintain is keep on the work on a regular basis. Cool. Chalo. Now, sir, what is a calomel electrode, master? So, beta, this calomel electrode is the electrode of mercury. Sir, we know that if you have, let's say, water, and sir, water is not a conductor. So if I use mercury, sir, mercury hai, sir, mercury ion, which mercury ion? Sir, Hg in +1 state. But sir, Hg in +1 state exists as a dimer. So what salt I use in calomel electrode to bring that ion to me? Hg2Cl2. You can obviously see that's a dimer, but mercury here is present in +1 oxidation state. Now there is one more problem with this salt. Beta, this salt is a sparingly soluble salt. It do not dissociate in water much. It is a sparingly soluble salt. So very few amount of this mercury will be creating Hg plus ions. Then sir, how come it is giving me these Hg plus ions to a very small extent? Yes, so very small amount of mercuric ions also, and very small amount of chloride ions also. Why? Because that's a sparingly soluble salt for us. Sir, but these limited number of ions will not be able to make this solution conducting. No. So in order to make this conducting, I add some strong electrolyte which is having Cl minus ion. Sir, but that will disturb this equilibrium. Yes, because it is already a sparingly soluble salt. If you add Cl minus ion sufficiently, then its equilibrium will be shifted in backward direction. Be it at least you are having few Hg plus ions. Yes, sir. Those Hg plus ions, the moment they are formed, they will be reacted. And if they are reacted, this equilibrium will feel array, and Lee-Chatelier principle will keep on breaking this mercury slowly, the amount that you require for the electronic transaction. So technically, this calomel electrode is nothing, but this is electrode of mercury. Let us write its reaction. Let us write its oxidation half. Sir, if you have mercury, but sir, mercury, there is problem with mercury as well. What? That at room temperature, it exists at in liquid state. Yes. So actually this Hg is giving Hg plus, but sir, Hg plus do not exist as this, it exists as a dimer. That too, the salt which is furnishing the Hg plus ions is Hg2 plus 2 solid. Okay, no issues, because it will be furnishing at least limited number of ions, which is sufficient enough for my electronic conduction, for the electronic transaction. Yes, to make the solution conducting, I have added externally Cl minus ion. Let's say I have added Cl minus ion using any strong electrolyte KCl. So KCl will give sufficient number of ions to make the solution conducting. Acha, master. So this is my half reaction. So this from zero oxidation state, it is coming to +1 oxidation state. Acha, sir. That means it is losing electron. Yes. But sir, this is not balanced. Array, you have added na Cl minus ion. So add Cl minus ion, sir. There you have 2 chlorine. So add those Cl minus ions. But sir, now charge is not balanced, so no issues, make it 2. Now, sir, just this 2 will balance mercury also. So this is the oxidation half reaction for this calomel electrode. Reverse this, it will be reduction half reaction. Use this calomel electrode with any other metal. Connect a battery, connect a voltmeter, you will get a potential. So this, what will be the electrode potential for this guy? So it's electrode potential because this is an electrode. This is the oxidation half of the reaction. So what will be, let us write the oxidation half only. So if it is used as an anode, it will oxidize. So what will be the oxidation half? Sir, oxidation potential of this electrode will be Nernst equation, sir. So electrode potential of, because I'm writing oxidation potential, so Hg is turning to Hg2Cl2. But yes, sir, in order to make Hg2Cl2 in the solution and to make it conducting, I even need chloride ions. This chloride ions I'm definitely adding from a strong electrolyte. So this becomes a metal, but in liquid state, insoluble salt anion electrode, which is, if you use this for mercury, it is also termed as a calomel electrode. Sir, so electrode potential will be equal to standard electrode potential, E naught of this same thing. I hope everybody remember, not plus, we have done that error. So minus RT upon NF into ln of Q. Now, what will be the reaction quotient? Sir, this is pure solid, will not impact equilibrium. So this will impact. So pure liquid do not impact equilibrium. So concentration of Cl minus ion raised to the power 2 will be the reaction quotient. And sir, that chloride I'm adding from a strong electrolyte whose concentration I'll be knowing. So yes, you can do, and sir, this is 1/2 of the reaction. Use it with any other reaction. I can calculate cell potential as well. Hello, guys. So standard hydrogen electrode, beta, we have Harshit Pandey. We have already revised it with the first question. Cool, everybody? Chalo. Cool. Shall we move forward? Guys, chalo. Master, acha, where is my slide changer? Master, this much is done. So we know 3 types of electrode. Now, moving to the next type of electrode is a redox electrode. So, sir, what is a redox electrode? Beta, whenever you are having one ion transforming into another ion, so that is technically called a redox. Sir, I will be 1/2, the another half will also be doing it. I didn't get it, sir. So the best thing to get redox electrode is with the question. So let's say I have represented this cell. This is how you represent a cell. The first half, which is on the left side of the salt bridge, is the anode half of the reaction. So this is my anode half. And the second half obviously represents the cathode half. Yes, this should be a single line. That's a typo error. Why we use these separator? They are phase separators, beta, because these are aqueous ions and platinum is a solid. This is a separator, phase separator, solid and aqueous. Why you write a comma? Whenever physical state is same, we represent with a comma. Now, sir, ions can't have a solid metal physical state. Yes. So again, inert metal we will use. in that inert metal, the ions will get adsorbed. Maybe we have used the salt which are having these ions. Now, sir, who is getting oxidized? Beta, chromium from +3 to +6. Who is getting reduced? Sir, tin from +4 to +2. And there, sir, electrode potential is also given. And now the question is asking us, so this is a best example of what electrode? So this is a redox. Both of them are redox electrodes. Now, let us understand redox electrode, which we understood. Now, let us do mathematics also. So, the question is asking us to calculate cell potential. Arey, easy, master. Again, Nernst equation, sir. Yes, beta. So, according to Nernst equation, sir, cell potential will be equal to standard cell potential minus 0.059 upon number of electron transferred. The +3 to +6 as in 3, and here +4 to +2 as in 2. So if here the electron transferred is 3 and over here the electron transferred is 2, then how can we make them equal, sir? Come on, yaar. Multiply 3 here, multiply 2 here. So that means number of electron transferred is nothing but 6. Easy, sir. Now, into log of, but sir, log of what? Beta, now in order to write the reaction, I can definitely calculate E naught cell because these data are given. But sir, what will be Q? For that you have to balance the reaction. So let us now balance the reaction. Here balancing of reaction is required. Okay. Sir, so chromium +3 is transforming and forming chromium +6. And sir, tin +4 is transforming and forming tin +2. So these are the two half reactions. Now, I guess balancing them is also easy. Why? Because we already know that we have to multiply chromium with a 2. So use 2 here. Obviously, 2 will form 2. So they are transferring 6 electrons, 3 electrons, but 3 into 2 will make them 6. So electron transfer is also balanced. Chromium is also balanced. But sir, tin will be multiplied with a multiplier 3 because 3 into 2 will make it 6. And so now atoms is also balanced. Sir, that means we know the stoichiometry also. So Q will be Cr plus 3 constant, Cr plus 6 concentration raised to the power 2 into tin plus 2 concentration raised to the power 3 upon Cr plus 3 concentration raised to the power 2 into tin plus 4 concentration raised to the power 3. Obviously, their concentration will be given in the question. Like for example here, so we are just generalizing because it is not asking us to do the math. It is asking us to understand the common sense. Acha, sir. So now the only thing we need is E naught cell. So what will be E naught cell, sir? E naught cell will be E naught cathode. Now who is cathode? Sir, tin. So for tin, do we have a reduction potential? Yes. So this is B minus. Sir, oxidation, electrode potential as in reduction potential of anode. Sir, is it reduction potential? No. From +3 to +6, it is oxidation potential. So its reduction potential will be E naught Cr plus 6 to Cr plus 3. This is reduction potential. So given is A volt. So this will be minus A volt because this is oxidation potential. We have to write the reduction potential. So, and this is acting as anode. So cathode minus anode. So anode is minus A. I hope everybody is clear. Now, sir, that means this is B minus A. So let us use this B plus A minus 0.059 upon 6 into log of this Q. Which Q? Sir, this Q. Hello? Sir, ion concentration, if they are given, good. Sir, let's say because it is asking, let's say it is standard condition, so all the concentration will be 1. So, sir, log 1 will be 0. So this will be your value, B plus A. I hope everybody is clear. Guys need confirmation. Guys need confirmation. Hello. Cool. Cool. Chalo. Moving to cool. Shall we move forward? So all the students who are practicing writing with me, give a heads up because master needs confirmation. Quick. Chalo. Now, so moving forward, coming to the last type of electrode, which is metal insoluble salt anion electrode. Arey master, what is this? Arey beta, we have already used it because calomel electrode also is of this kind. But the only difference is once we are talking for this one, I definitely mean thickness I should increase, है ना? Yes, so this is beautiful now. So let us take the famous example which JEE do not love. Mains, advanced, they love like anything. So the famous example of metal insoluble salt anion electrode is of that silver electrode. Okay, sir. So let's say beta, if you have silver, if you have water, okay, sir. And let's say if I have used AgNO3, then sir, AgNO3 na, this is a silver salt which is a strong electrolyte. So it will completely dissociate and gives me silver plus ions. Now sir, you dip silver metal into it because silver is a solid. And then use it. So this is one electrode. So use it with any other electrode. They will create a battery, a cell, which will give you current. Okay, sir. That electrochemical cell logic we have done in the previous class. So I'm not going over there. Acha, master. So acha, this is also one. But sir, this is normal metal ion electrode, sir. This is normal, sir. This is a normal metal ion electrode. Yes, not denying to this. So how can you write Nernst equation? So electrode potential of Ag plus 2 Ag will be equal to what? Sir, this is just metal ion electrode. So it will be standard electrode potential, master, minus RT upon NF, master. So because, acha, let us write NF into ln of Q. And what will be Q, sir? If you write what is the reduction half for this reaction, sir? Simple, sir. Ag plus aqueous, which is present in the solution, it will take one electron and it will form Ag solid, sir. So this is simple. So sir, pure solid is 1, so that means it is 1 upon Ag plus concentration at equilibrium raised to the power 1. Easy, sir. Okay, agreed. So electrode potential is equal to standard electrode potential minus this, sir. This is just metal ion electrode. But I am asking you, my friends, let me just duplicate the slide. I am asking you, my friends, that you do not do this, sir, but you have done this. Arey, nahi, I'm just comparing. That was a metal ion electrode. Now the thing that I'm changing over here is I am not using a sparingly soluble salt. Okay. I am not using a sparingly soluble salt. Soluble salt. Rather, I am using a sparingly soluble. That was a soluble salt. I'm sorry. AgNO3 was a soluble salt. Completely dissociates. Sir, generally these salts are ionic compounds. Sir, ionic compounds will be complete electrolyte. But now I am using AgCl. Although AgCl is a white PPT, but still because white I have already drawn. Acha, so change. Okay, beta, changing. Because it will confuse some. So let me change this complete color. So let me make it blue color, and now I can beautifully draw this as white. Now this is good. So sir, this AgCl, sir, this AgCl is a sparingly soluble salt. It do not dissociate. Sir, if you use AgCl, na, it will very partially dissociate as Ag plus and Cl minus. Sir, very limited number of ions. Arey master, then again it is a problem. I can have silver interacting with Ag plus, the limited thing can be done. Why? Because once you remove silver, Lee-Chatelier principle will again create few amount of silver, the same amount it want to furnish. But sir, then water will not be conducting. So again, sir, you have to use, in order to make this solution conducting, you have to externally add some ions. Sir, what ion? I'll add common ion. So I'm adding Cl minus, but from a strong electrolyte. Now I hope everybody can see. So this is a metal insoluble salt anion electrode. I hope everybody get it. I hope everybody get it. Guys, need confirmation here. Now we will find out its electrode potential and standard electrode potential, but give me a confirmation everybody is with me till here. Cool. Guys, need confirmation. Chal. Cool. Got it, sir. Okay, Upamanyu is with us. Great. Chalo. So Upamanyu, be with us. Take out your pen and copy. Start practicing. Hai Chalo. Great. Sorry, sir. In middle, my current was cut off. No issues. Upamanyu. Great. Chalo. Anita. Okay. Chalo. So, chalo, Upamanyu is also here, and now I guess we are good to go, and we all are studying. Take out your pen and copy and attend, beta. This is a very interesting chapter. Chalo. Acha, master. Let us proceed. Okay, beta. So, this is a metal insoluble salt. Now we need to calculate its electrode potential and standard electrode potential. We will derive it conceptually, but yes, after deriving, now I will definitely urge that you should remember the conclusion. It will help in mains, advanced examination, like anything. Sir, if I have written this equation, then I can, okay, so let us, sir, if you have written this, then use it. So this is the first equation that I have already used. Okay, sir. So for this equation, can I say, if it reaches equilibrium and at standard condition, sir, delta G, sir, because this is Gibbs free energy. So delta G for this reaction will be what? This at standard condition. The delta G is equal to delta G naught plus RT ln Q at equilibrium. No work, so delta G is 0. So delta G naught will be equal to minus RT ln of K. And this K will be KSP because this is a sparingly soluble salt, and for these sparingly soluble salt, the KSP value is definitely given, which signify that they are sparingly soluble salt. Most of the question have that value if they are serving that question to you. So this is delta G naught for this reaction. Let us say this is delta G naught 1. Why? Because I will be needing few reactions just to do the mathematical ideology. Acha master. So sir, you have already told us for the metal ion electrode. Sir, for this metal ion electrode, yes. So for this metal ion electrode, sir, if you use Ag plus aqueous, it will take electron and it will form Ag solid. Yes. So for this reaction, sir, can you also write the value of delta G? Huh? For this, I can also write delta G naught. Let us say this is the second reaction that I'm using. Then for this, sir, use the conclusion. Delta G is the work which is N minus NFE naught minus number of electron transferred N, F and E naught, as in the standard potential of this half reaction. Sir, but what is this? Sir, this is metal ion electrode. So this is E naught of M, or rather because I have used silver, so let me write of Ag plus 2Ag, because this is my simple metal ion electrode. This is my simple metal ion electrode. Cool, sir. And if I add these two reactions, you will see the beauty. If I add these two reactions, you will see the beauty that master Ag plus and Ag plus is getting cancelled. So LHS, I am having AgCl solid. Then I am having one electron. It is giving, sir, silver solid plus Cl minus. Array, master, this is metal insoluble salt taking electron, getting reduced to form silver, and sir, in presence of the common ion that you are providing to make this water conducting, sir, that means this is the half reaction for the reduction half of metal insoluble salt anion electrode. Acha, sir. So if here also I will write delta G, then how can I write delta G of this reaction at standard condition? Array master, no issues. No issues, sir, because delta G is a state function, sir, thermodynamically. So whether you are following any path, I do not care, sir. If you are adding to reaction, the state function will do not bother what path you have followed. So what will be delta G for that reaction, sir? Because delta G is an extensive quantity, sir. So how you have got this reaction? By adding these two reactions, are master, then delta G will be equal to delta G1 naught plus delta G2 naught. Just add them, sir. And delta G naught is equal to minus NF E naught for that particular cell. And this is what? Sir, this is metal insoluble salt anion electrode. Acha, master. This is good, sir. So we are utilizing the trick of thermodynamics now. That means, master, this delta G naught can be written as minus NF E naught of this electrode. What is this electrode? Sir, here AgCl solid is transforming to, because this is also solid, although it is transforming, but I will use a comma because both are in same state. But yes, this AgCl is not alone, sir. This is made conducting by using Cl minus ion. So phase separator and then Cl minus ion. So this will represent the standard potential for metal insoluble salt anion electrode. And this will be equal to what? Master, this thing will be equal to, sir, delta G naught 1. What is delta G naught 1? Sir, it is minus RT ln of KSP plus delta G2. What is delta G2? Sir, again, because that's a minus, so I'm using minus NF E naught of metal insoluble metal ion electrode. This is simple metal ion electrode, sir. Acha, sir, so we have related them. Yes. So technically beta, if somebody is asking you to calculate, the standard potential. So technically, sir, this minus, and this minus is gone. Definitely, if I need standard potential of metal insoluble salt anion electrode, then it is equal to standard potential of normal metal ion electrode, because now this is also plus. This NF and this NF is gone. So this NF and this NF are gone. Yes, I will have NF here. I'm writing this as first. So this is equal to standard potential of normal metal ion electrode plus RT upon NF into ln of ASP. Master, great. But beta, remember this conclusion. Please learn. Because I do not know how many times mains has asked this just directly. No. Other conclusions directly. So everybody, just give me a confirmation. Just give me a confirmation, everybody. Cool. Just give me a confirmation, everybody. Cooler, guys. Perfectly understood. Great. All clear. Great. Chalo. Shall we move forward? Acha. I'm definitely again telling one thing, everybody. So how to remember this? Sir, standard potential, sir, because this is metal insoluble salt anion electrode. Sir, this is metal ion electrode. Sir, so why their standard potential will be same? Because they are different cell. Sir, here complete Ag plus is formed. Sir, here very limited Ag plus will be furnished. In order to make this conducting, sir, I am using some other ion which is making this equilibrium go mad. It is in backward direction like anything. But yes, at least small amount will be given, and that small amount of Ag plus will be required by this for the redox half. I mean, what it will be some if this half cell will be connected with another half cell, so it will be one half of that redox. So for that electron transaction, you have limited number of Ag plus, but I'm not mentioning that Ag plus as free Ag plus. I'm mentioning that as solid because the hell it is not getting soluble. It is a sparingly soluble salt. So sir, standard potential of a sparingly soluble salt is equal to standard potential of a normal metal ion electrode, but it is not completely equal, sir. You have to add RT upon NF into ln of KSP. Sir, for this case, value of N is what? For this case, value of N is 1. So I can put the value, and sir, KSP I will put for AgCl. Sir, then okay, this is done, sir. So standard value is not same. But you know what? The beauty, standard value is not same. But this is beauty of God. And what is that beauty? That reduction potential of metal insoluble salt of the insoluble salt electrode. Insoluble salt electrode. They are equal. That means I'm saying electrode potential of Ag plus 1 getting Ag. So this is a reduction potential of this insoluble salt. It is equal to electrode potential of metal ion electrode. Hai, master? Yes. Sir, why? Let us prove this. Sir, their standard value are not equal, but their actual reduction potential is equal. Why, master? Now let us prove that. Why their reduction potential are equal. Now, let us write Nernst equation. Let us write Nernst equation for this. Okay, sir. Let us write Nernst equation for this. So according to Nernst equation, standard potential will be equal to, cell potential or electrode potential, because this is an electrode. So electrode potential will be equal to standard electrode potential minus RT upon NF into ln of reaction quotient Q. Now, what is the reaction that we know, sir? This is the reaction for metal insoluble salt anion electrode. Sir, pure solid will not bother. Sir, concentration of Cl minus ion. Sir, pure solid will not bother. So this Q will be nothing but, sir, it will be concentration of Cl minus ion at equilibrium. And whatever be the Cl minus ion, sir, it will be added by strong electrolyte. So what? So what? Sir, value of K do not depend upon the concentration. So this will get depressed and ultimately again equilibrium will be reached. And at equilibrium, master, we know K value is equal to Ag plus concentration at equilibrium into Cl minus ion concentration at, array master, whatever is this value, whatever this has created, whatever the strong electrolyte has created, the combined value is Cl minus ion concentration. So this value will be equal to Ksp upon Ag plus concentration. Hello, let us replace. So this value will be equal to this value, or I can say everything else is same. So the only thing that is going to change is ln of instead of Cl minus ion concentration, I can write Ksp upon, intentionally I'm not doing upon Ag plus concentration at equilibrium. Why I'm writing that this? Because log of A into B I have to apply. So if I apply log of A into B, then what I am going to get, master? I hope everybody can beautifully see this because magic is going to happen. So log of A into B is ln A plus ln B, because I have a minus over here. So again, minus RT upon NF into ln of 1 upon Ag plus concentration. Hello. Acha, master. Then sir, what has happened? Let us see the magic. Now sir, we have derived one relation for standard potential. So electrode potential of reduction potential of metal ion electrode. Now what is this? Can anybody tell me what is this? Have you seen this anywhere else? Yes. Where? Sir, in the previous slide. Sir, E naught of metal insoluble salt, metal insoluble salt, metal anion electrode minus, you bring that this side, so minus RT upon NF into ln of KSP, because over there you have a minus. See, that means sir, whatever, if you do that minus thing sir, you will get this, because this standard value minus RT upon NF into ln of KSP is nothing but E naught of metal ion electrode simple. Hi, sir, that means this is nothing but E naught of metal ion electrode. Acha, sir. So this is E naught of metal ion electrode. Now you tell me how you will write. I hope everybody has got this much. Hello, I need confirmation. Hello, I need confirmation. Acha. So sir, this is electrode potential of metal ion electrode. And here I have E naught of metal ion minus RT upon NF into ln of this. Now sir, what is this? What is this value? This complete thing. Let me write it again. So this RHS is what? E naught of Ag plus 2 Ag minus RT upon NF into ln of 1 upon Ag plus concentration. Can you tell me, have you seen this anywhere? Arey, haan, master. This is electrode potential of normal metal ion electrode. Where you have written that? So let us write this. This is a normal metal ion electrode. What will be its electrode potential? Sir, electrode potential will be equal to standard electrode potential minus RT upon NF into ln of reaction quotient for this. Sir, product is pure solid, so 1 won't impact equilibrium. Sir, upon Ag plus. Array, master. This is Nernst equation and this is equal to what, sir? This is equal to this value, which is electrode potential of metal ion electrode. And this RHS I'm having here. That means, master, this is nothing. This is nothing, but this is equal to electrode potential of simple metal ion electrode. Hence proved, sir. Hello. Hello. But yes, I'm definitely suggesting each and everybody. Please remember this. Please learn this. This is not important. This is very important. Cool. Cool. Need confirmations, guys. Whoever is with me, respond and confirm this. Sir, I'm in Laksh batch. I have full backlogs of this chapter. Sit if I just watch this lecture and do all lectures slide question. Beta, it is not more than enough. Mikhail, beta, that is not more than enough. That is the best, beta. That is the reason we are doing this one shots. So that is not, you are saying it is sufficient. No, 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 it is more than sufficient. Mikhail, please do that, beta. Cool, cooler, cooler. Chalo. Shall we move forward? Done. Need confirmations. Mikhail, Upamanyu. Chalo. That means we can move forward. Now, sir, after the types of electrode, let us practice few questions. See, I am giving you multiple questions, but obviously, sir, we some of these questions we can do. So let us see which one. So I'm just putting question numbers 1, 2, 3, 4, 5, 6. So 6 questions we have in order to completely understand application of Nernst equation with that logic of metal-insoluble salt, because they have variety of questions. So if you do these 5 questions, actually you will get all the type of questions that are asked in even JEE Advanced. Okay, chalo. Now, anybody has some special preference? Because obviously you also have to try, because I have explained everything with utmost detail. But yes, out of these 5 questions, any special preference? So hit the comment section with 1, 2, 3, 4, 5. I will do that one for you. Let me show these 6 questions again. So 6, 5, 4, 3, 2, 1. So which one? Which one? Chalo. That means it is up to your master's wish. So let us do the last one. Let us do the last one. Quick, everybody. So this is the question that we intend to do, and time for the question, integer type question, I guess. So you have to find a ratio. I guess the ratio will be so integer type question, but I'm giving you 2 minutes for this. Quick beta, because you have to do that mathematics. But because you have to report answer, na, so you just tell me the ratio of Cl minus ion concentration upon Br minus ion, because you, in that way you can report this as an integer. So you give me the opposite ratio, Cl minus upon Br minus. Okay, chalo. At least read the question, everybody. The minimum you can do is you can read the question very properly. It is actually going to help you a lot. These concepts, all the questions which I have given. But yes, obviously with time constraint, we cannot attempt all, but we can attempt few. Chalo. At least I hope people have attempted this properly. Cool. Chalo. Now, let's start. Sir, I want to connect with you. Beta, here we are connecting. What else we are doing? So yes, the more you can connect with your mentor, with your teacher, is by practicing questions with more and more efficiency. Acha, chalo sir. So I just want to see how many of you have done this. Chalo. Let us solve this beta. A good one, because yes, it will teach us every logic properly. Now, sir, first of all, the cell representation is given. So this being the anode half. So for this anode half of the reaction, let us, because sir, we need to first write the complete reaction. So let us write the reaction. Sir, silver is getting oxidized from 0 to +1. But sir, this is metal insoluble salt anion electrode. So what, sir? And it is getting oxidized. So that means, master, Ag solid is getting oxidized and forming Ag plus, but that Ag plus is not free, sir. It is a insoluble salt, but ultimately redox is happening because it is giving electron. But sir, in order to balance this, I need Br minus in the left hand side, because this is the half that we are talking of. And sir, because it is an oxidation half, so obviously silver will give electron. Okay, sir, charge is also balanced, atom is also balanced, and this is my first half, oxidation half. Who is getting reduced? Master, this guy is getting reduced. And sir, the guy that is getting reduced is also metal insoluble salt anion electrode. So be it. Acha. Then sir, who is getting reduced? I guess Cl minus ion is written twice, not required. So one. Acha. So that means AgCl solid, where Ag is in +1 oxidation state. Sir, this is getting reduced to silver solid. That means, sir, it is gaining electron. Acha. And sir, in order to balance the elements, sir, it will be conducting because of the extra added Cl minus ion. So this is my, sir, first is my oxidation half and second is my reduction half. And sir, in order to get the complete reaction, you simply have to add them. So let us add and write the full cell reaction. So full cell reaction. Acha, master, will be what? Beta, full cell reaction will be, you just add them. Okay. Anything is getting cancelled? No, sir. Only electron getting cancelled. Acha. So, sir, this is Ag solid plus AgCl solid plus Br minus. Sir, the only thing that will change, that will be impacting the state of equilibrium is this, because pure solid is, we are not bothered. Acha. Will give, sir, it will give the product, sir. I hope everybody can see, master, HBr solid. Then you have silver solid. And it is giving master Cl minus aqueous. Acha, master, only this is impacting. Very good, master. Okay. Now, sir, let us write Nernst equation. Okay. So, according to Nernst equation, cell potential will be equal to standard cell potential minus RT upon NF. What will be N beta? Number of electron transferred is 1. So, killed, N is also killed. Sir, into ln of Q. But the question is asking you, you have to give this ratio when EMF is 0. Arey master, when EMF is 0, that means equilibrium has been reached. So when EMF will be 0, sir, this will be 0 when equilibrium is reached, sir. So at equilibrium, E cell will be 0. That means E naught cell will be equal to positive of RT upon F, and this ln will become ln of K. And what is this K? Let us write the value of K directly. So, sir, K will be concentration of product, which is Cl minus at equilibrium, upon concentration of master Br minus at equilibrium. Acha, master, this concentration I need. Oh ho ho ho. So ultimately we have reached that this X I need. Good, sir. Let us make this as equation 1, which is equal to E naught cell. And sir, we can also find another equation for E naught cell. How? Sir, E naught cell is equal to E naught cathode and E naught anode. And who are these cathode and anode? Sir, cathode and anode are metal insoluble salt anion electrode. And sir, for them, we know how to write their standard potential. Standard potential for them will be equal to standard potential of normal metal ion electrode plus RT upon NF into log of their KSP. Hello. Acha. So sir, now I know I have to calculate this E naught cell with utmost common sense. So let us do that in the second page. So also sir, I can calculate E naught cell, sir, because E naught cell will be E naught of cathode. Now who is cathode? Let us first check that. So this is cathode. And what potential I will put? Sir, reduction potential. So reduction potential when AgCl, metal insoluble salt, is used. So in presence of Cl minus, AgCl will give you Ag. This is cathode minus. Who is anode? So bromine 1. So E naught Br minus is the common ion and AgBr is getting reduced to Ag. Acha, sir. Sir, that means let us put these values, or I can say E naught cell is equal to. Now let us do it for this first. Sir, standard potential was not same, sir. Standard potential was equal to standard potential of simple metal ion electrode plus RT upon NF. Obviously, one electron is transferred, so 1F into ln of KSP. So this will be KSP, but KSP of whom? Your or mine? Sir, of AgCl. So this is of cathode minus of this anode. But sir, again I will write reduction potential. Acha beta. So write reduction potential. Sir, metal insoluble salt standard potential is not same. It is equal to standard potential of the simple. Hey, what is your simple metal ion? Sir, it is E naught Ag plus 2Ag plus RT upon 1F, because electron transferred is 1, into ln of KSP of whom? KSP of you. Who are you? You are sparingly soluble salt of AgBr. Acha, master. Then it is simplified, master. How? Beta, this is plus and this is minus. So this is gone. Neither it is not given in the question as well. So this will be equal to E naught cell. So this E naught cell is equal to, sir, RT upon F will come common, sir. So RT upon F taking common. So ln of KSP. But KSP of what? Sir, ln A minus ln B. So ln of A by B. So KSP of AgCl upon KSP of AgBr. And I guess these values are given to us. Haan, sir. KSP of AgCl is given as 10 raised to the power minus 10. So this value is 10 raised to the power minus 10. And of AgBr, it is 5 into 10 raised to the power minus 13. So this is 5 into 10 raised to the power minus 13. And so this complete thing is also equal to E naught cell. And equation 1 is also equal to E naught cell. So by equation 1 and 2, by 1 and 2, I can say both are E naught cell. So sir, RT upon F into ln of minus 10, sir, this will be plus 13. So I will have 1000 because 10 is power 3 plus 3 as in 1000 by 5. But this will be equal to what? So this will be equal to this, which is RT upon F into ln of Cl minus concentration upon Br minus concentration. And I guess this ratio we are supposed to calculate for the question. So obviously RT upon F gone. That means, sir, I do not even have to solve log, because this log of this is equal to ln of as in log base e. So this is nothing but 1000 upon 5. That means 200. So answer is 200. Hello. 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 Can I write it as E naught cell is equal to uh, Mikhail? I hope you have beta that thing E naught cell is equal to that. I guess that is long back. Here we are discussing good questions. Cool. Need confirmations. ज़्यादा हुआ? Eh? I hope whoever is listening to me properly will not be feeling. Actually, this is good question, beta. This is actually a good logic. This is what advanced do. Mains also has started doing it for electrochemistry. That's why I was intending to take electrochemistry in 2 halves. Okay. Done. Mikhail, are you sure? Huh? If at all, Mikhail, it is coming, so it is good. If at all it is coming, Mikhail, so it is good. But yes, be logical about it is what I'm just saying. That's why I have, or else I could have just written the, sir, beta reduction potential is just equal of metal and normal metal ion electrode, and standard potential is equal to, standard potential of insoluble salt is equal to of simple metal ion. But you have to add plus RT. But I have made it, derived it for you, because that gives you a sense of responsibility. Cool? Cooler? Char. नहीं, Mikhail, first part is already done, beta. Kindly just after the live is done, no, kindly start the live from the beginning. Over there, I have even shown the first part. The first part, which I've done 1 month back in the same live section, I've just shown it. So just go to the start. You will be directed how to reach the first part. Cool, Mikhail? So this is the second part. First, we have already done. After this, your electrochemistry will be good. Cool. Shall we move forward, guys? Shall we move forward? Chalo. So moving to the concept of electrolysis. So moving to the concept of electrolysis. Now, moving to the concept of electrolysis. Now, what does the concept of electrolysis is going to tell you? Sir, concept of electrolysis is just dealing. Cool. So concept of electrolysis is just dealing, sir, for electrochemical cell. What we do, we make a spontaneous chemical reaction to happen, and that spontaneous chemical reaction produces current, sir. So that is a battery. That is an electrochemical cell for us. So what is the opposite, sir? If you pass electricity, then a change, a chemical change, which is rather non-spontaneous, but I will be forcing that non-spontaneous reaction to happen. I will be forcing that non-spontaneous chemical change to happen by supplying current electricity from outside, and then that cell becomes electrolytic cell, and the process that is happening inside is nothing but process of electrolysis. So basically this electrolysis is the process of decomposition of an electrolyte on passing electricity or electrical current through its aqueous solution or even molten state. And the apparatus in which it is done, as in this, is your electrolytic cell. Now that means that you are externally connecting battery, yes. So from where I have connected the positive terminal, that electrode will become positively charged. And the battery, the negative terminal of the battery is connected to this electrode, so this will become negatively charged. Obviously we know, sir, current is flowing in this direction. That means, master, electron is flowing in this direction. So who releases electrons, sir? The electrode, the compartment, the side which is releasing electron is getting oxidized, and the electrode at which oxidation take place is termed as anode, sir. That means in electrolytic cell, sir, anode will be the positively charged terminal. In electrochemical cell, anode was the negatively charged terminal. And obviously, cathode, because it is releasing, so it is gaining electrons. So that means here reduction is taking place, and the electrode at which a reduction take place is called cathode. And here cathode is negatively charged. I hope everybody can see that now. Sir, if you have used a salt, then sir, in the plus electrode, who will come? Sir, negatively charged species. So anions will be attracted here, and anions will come and they will give electron. That means oxidation is taking place. So anions are oxidized. And cations will definitely be reduced because cations are positively charged. So they will be attracted toward the negatively charged terminal, and cation will gain electrons, so they will undergo reduction. That means, sir, I will be getting product at each electrodes, and these products are called product of electrolysis. Point number one. So the first analysis that we do over here is what type of product is produced. So the type of product produced, if we are identifying it, that is called qualitative analysis. The second analysis will be how much of these products are, maybe if the product is a solid, so it will just get decomposed, it will just get deposited here. So the second analysis will be what is the amount of electrolyte which has been deposited at electrodes, and maybe if B plus is getting reduced, then it may form some gaseous molecule, so gas will be liberated. So what amount of gas has been liberated? That will be, again, obviously, what amount as in quantity. You are calculating, you are trying to calculate the quantity. So that will be covered under quantitative analysis. Cool. Now, sir, that means now we have to do two type of analysis. What is produced and how much is produced. So let us first deal. So let us first deal with the qualitative analysis. Let us first deal with the qualitative analysis. Sir, so discussing about qualitative analysis, let us first take an electrolyte which is molten. If I have any molten electrolyte, let's say any molten electrolyte. Okay, so let me take an example. Sir, if I have, let's say in the same compartment, if I'm just having no water, I'm just having molten NaCl, for example, just I'm having malt. So this is not aqueous beta, I'm writing liquid. Maybe I have increased the temperature and I'm forcing NaCl to liquefy. So now I have Na. Sir, why? Because beta, even ionic compounds are conducting, but in order to conduct, they have to be in liquid state. In solid state, the hell they can't conduct. And yes, if they are in liquid state, they can conduct. Now you can externally add an electrodes, and if you are connecting battery, so this will become positively charged, this will become negatively charged. That means this is my anode and this is my cathode. Why it is cathode anode? Because negative positive? No, master, it is anode because here oxidation will take place. Why oxidation will take place? Because sir, here Cl minus ion will come and it will give electron, and once it will give electrons, so that is oxidation. So at anode, oxidation takes place. And who is going to oxidize? Sir, Cl minus ion, because Cl minus liquid, not aqueous, is giving electron. If it gives electron, then obviously, sir, which state, what is the free state? In which state chlorine will be very, very stable to exist as, sir? Cl2 gas. And it will be releasing electrons. That means what is the product of electrolysis at anode? You will say chlorine. Beta, many times mains just ask this, the product of electrolysis. So one option will be chlorine gas is created at anode. And what about cathode, sir? What about cathode, master? At cathode, reduction will take place. So, sir, Na plus, because it is releasing electron. So how you can release electron? Somebody has to gain that electron. So Na plus, but no aqueous. In liquid state will be gaining that electron and will be forming sodium solid. Hello? Hello? Guys need confirmation. Guys need confirmations. Done. Done. Chalo. So, sir, acha, one more thing, beta. In general, in general, if it is not mentioned, like for example, it is just saying electrolysis of molten electrolyte, that means you need electrolyte in liquid state, molten state. And nothing is mentioned about the electrodes. Then if nothing is mentioned, I will consider these electrodes as inert. Sir, if they will start participating, then beta, it will be different. So here nothing is mentioned. So I am assuming these electrodes are inert electrodes. So I'm assuming these electrodes are inert electrodes. Sir, if it is mentioned, obviously whatever it is mentioned, you will take that. But sir, how? Obviously we will do examples, but yes, the JEE generally plays with these material of these electrodes, and obviously we have done electrochemical series in the previous half, and that's why I've taken time in discussion of that, because if you do that, then definitely, although I'm going to discuss everything here, but yes, it will be more and more practically clear to you. Cool. Chalo. Now let us move forward. So sir, next one is electrolysis of aqueous electrolyte. So what example of aqueous electrolyte I'm taking? Sir, of H2SO4. So sir, again sir, that means here master, instead of NaCl you are just taking H2SO4, but now you are taking aqueous electrolyte. So obviously that H2SO4 will also conduct, but it is present where, sir? It is present in water. So what will happen with water, sir? Na. Water will also participate, because water also has a tendency to oxidize also and reduce also. Then sir, if there are more species who are competing to undergo oxidation or reduction, then this is nothing but competitive electron transfer. And who is going to win this competition? If you and your friend, both of you are giving JEE examination, then who is going to go to IIT Bombay Computer Science? The person who is getting a better rank, who is having better potential. So now you will require that electrochemical series. Sir, shall we remember the values? Nahin, but the trend. So remember the rhyme that I have given? Yes. Sir, with that electrochemical series we have read only for the metals, and yes, sometimes you even have to read them for anions, and hence we have done a list of anions comparison also. I will again do that comparison, but I hope you remember that thing. Chalo. Sir, that means let us find the product of electrolysis. So sir, at anode, where oxidation is taking place, and for electrolytic cell, anode will be positively charged. So who will approach positively charged anode of electrolytic cell? Sir, the negative ions, because at anode oxidation take place. So sulfate SO4 2 minus can also approach, because minus will be attracted towards plus, and it will also try to undergo oxidation. Yes, it can definitely undergo oxidation, and it can form peroxo disulfate, peroxo disulfate. But technically, beta, let me brief you with the common sense. It can undergo oxidation, you can learn its oxidation potential, but not required. Why? Use basic common sense of chemical bonding. What is the oxidation state sulfur is having over here? +6. do you feel this? Sir, sulfur has already given electrons. Sulfur has, sir, if somebody is present in its maximum oxidation state, can't you think by just your chemical bonding basic that, sir, it is already present in its maximum oxidation state, sir, it can't further get oxidized. Then the hell who will have to give electron? Sir, oxygen. And it will give. Let me just brief you with this. Actually, oxidation happens. This is one sulfate ion. This is another sulfate ion, and the another fourth oxygen, this and fourth oxygen of that, both of these oxygen gives electron. If they give electron, they form a peroxide linkage. So actually this has given one, this has given. It can give two electrons. But beta, its oxidation potential, the value of E naught is very, 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 very less. So shall we remember this? No, don't. But this is important for redox half. But sir, we know this is very difficult to be oxidized. So rather, whenever you have sulfate, it will lose. It will lose with whom? Sir, who is competing? Arey beta, water is competing because you have aqueous ions. So now water will also participate. Sir, how can, arey yaar, here also oxygen can give electron because OH minus is there. Acha. So sir, but water is not an electrolyte. So I am not writing H plus and OH minus. I am writing water. If water gives electron, then who is going to give electron? Oxygen in -2 oxidation state. Sir, if let's say if oxygen has gone, then what will be remaining, sir? H plus ion. And sir, oxygen has given electron, and in which form oxygen will be happy? Sir, O2 gas. That means, sir, what is the redox that is taking place? Sir, oxygen from -2 oxidation state is turning to 0 oxidation state. Sir, this is oxidation. Now let us balance this reaction. So in order to balance oxygen, I will use 2. In order to balance hydrogen, I will use 4. And in order to balance charge, I will use 4 electrons. Acha, master. So this is happening in anode. So what will be the product of electrolysis? We will say oxygen gas is released at, what will we say? We will say oxygen gas is released at anode. I hope everybody is clear. I hope everybody is clear. Guys. Cool. I hope everybody is clear. Good. Chalo. Sir, then sir, this is at anode. Sir, what about cathode? Then beta at cathode. What is bound to happen at cathode? So sir, at cathode, reduction will take place because sir, this is a negatively charged terminal in case of electrolytic cell. So in negative charged terminal, who will come, sir? Positive ion. Who is positive ion, sir? H plus, because H2SO4 will give H plus. And this H plus will take electron and will form hydrogen gas. In order to balance this, 2 and 2. Okay, sir. But sir, we know, sir, standard potential of hydrogen is 0. But sir, what is the competition? Let us see the competition. This is 1. Here, the competition is won by this guy. This guy lost. Why? Because oxidation potential value is less. Do not compare value, because why learn that value? Common sense of chemical bonding has held. But sir, here this can also take place. Acha, you have placed a tick over here. No. Don't place tick. Let us do the competition. Who it will be competing with? Array, again, sir, water. Again, sir, water, because water can even gain electron because water has hydrogen in +1 oxidation state. Hydrogen can gain electron and form hydrogen gas. And if hydrogen gains electron and form hydrogen gas, sir, mediums become basic because H plus ion gone. So I have OH minus ion left. Water was not an electrolyte, but because hydrogen has gone, so now OH minus ion excess is left. Sir, in order to balance the reaction, I guess this is oxygen 1, oxygen 1. Charge is also 1. You just have to do half, then it is balanced, I guess. Yes, sir. Because 1 and 1, 2 hydrogens. Oxygen is 1, charge is also balanced. But sir, in any case, ultimately, what is the product produced? Ultimately, what is the product produced? Beta, product produced is hydrogen gas. So released. But sir, hydrogen is released with what half? hydrogen H plus ions are gaining electron or water is gaining electron? Yes. For those things, at least I am just suggesting everybody to learn the electrode potential of water. Water has two tendencies, to get oxidized also and to get reduced also. Hence, I just recommend everybody to at least read this data because it will help. Because during electrolysis, water can also compete with electrolytes. So learn these two value beta, it will help you. So if water is used as anode, then it will undergo oxidation. And if water is participating at cathode, it will undergo reduction. Oxidation potential of water is minus 1.23. This is oxidation potential. So reduction potential will be plus 1.23 of water. If you are writing this reaction, not of water, but I mean if you are writing this reaction opposite, if oxygen gain electron and forms water, that will be reduction half. So because we are competing for water, so I'm writing oxidation potential of water. And that means that this minus 1.23, that means from here I can conclude, because this is winning, that means this value is, this oxidation potential is even lesser than minus 1.23. Although you know, but yes, learn the value for water. Achha. And what is reduction potential of water? Sir, reduction potential of water is minus 0.83. Reduction potential of water is a negative of 0.83. Hello? Hello? So now if you know the value, that reduction potential of water is minus 0.83, that means this tendency, where it has gone? That means this tendency is having a potential of how much? Sir, minus 1.23 volt. Or so, not 1.23, 0.83. Sorry. This is minus 0.83. This is minus 0.83 volt. The reduction potential is this much. And sir, the reduction potential of this guy, the reduction potential of this half is 0 volt. Now you tell me mathematically which is more. So that is more. So again, hydrogen is created, but hydrogen is created because of this, not because of water taking electron. Hello. 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 Baby sing. Sir, Hindi please. I am very sorry, baby, because obviously you can see the name of the channel beta. We are supposed to, because we should be compassionate enough. There are many students beta who are rather not comfortable in learning in Hindi, because we have number of channels in PW also helping students like anything in Hindi. So this is the reason that we have created this separate funnel, that we already knew this from the beginning beta, that number of serious students eagerly waiting to learn in English is less. But we as PW, we always wish to, if at all there are 3 students, 4 students, and they are having a desire and they are having the energy to invest their energy so that they can maximize their future, the efficiency of their future, and there should be somebody, and hence this JEE channel is there, JEE English channel is there. Cool. Chalo. I hope everybody is good. Chalo. Now, sir, that means we have discussed this example of H2SO4. Moving forward. Now, sir, if we have reactive electrodes, everybody. Now, the example that I want everybody, every serious student who is there with me, I want you to make this common sense for electrolysis of aqueous copper sulfate, but I am asking you to give me the product of electrolysis once electrodes are not inert, rather electrodes are reactive, and I am having copper electrodes on both sides, and I am having copper electrodes on both the sides. Everybody make a prediction. Everybody make a prediction. Chalo, let us do it together. Sir, if you have copper, so first of all, sir, at anode, oxidation is going to take place. Anode is positively charged terminal, so negative ions. So who are my negative ions? Sir, sulfate ion can undergo oxidation. Sir, water can undergo oxidation. And now, sir, because you have a reactive electrode, so actually the electrode is also now copper. So, sir, that electrode can also undergo oxidation. Hello? That electrode can also undergo oxidation. And oxidation potential for copper will be, sir, copper will form copper plus 2 ions and it will create electrons. And sir, oxidation potential of water, sir, we have already seen that oxygen can give electron and can form hydrogen gas, sir, H plus ions and can create electron. So both of them can be used. Acha. For this beta, you obviously know. Now again, you can learn the value also. For water, I have given you that value. For copper also, you can learn the value. But sir, learning is difficult, sir. Give us common sense now. You tell me, water will give electron or metal will give electron. You tell me whose oxidation potential will be. Arey yaar, master. Metals are known as metals because they have tendency to give electron. Arey master, leave. Who will win? Copper. Why? I'm not even learning the value. I'm saying it will win because it will have higher, yeah, more tendency. Tendency to what? To give electron. Hello. Yes, obviously, the actual reason is the value of oxidation potential. Arey, master, but why? Learning in chemistry, sir, in organic, how much we have to? So at least wherever common sense is required, you take that common. Eh? Cool. Now, Satyam Kumar is saying, sir, I have a lot of backlogs in chemistry. Can you cover my syllabus for January attempt? Beta, the same intention we are having. Now, you just tell me, Satyam, how many students you see? You know, we always have limited. But beta, this limited students also once after the JEE exam, you will come and you will say, Arey, master. But yes, for that, you have to keep getting yourself involved. We will do complete JEE. The series is called JEE series. So we will be doing all the chapters of physics also, maths also, and obviously I am doing for chemistry also. Yes, you have to invest that energy, है ना? चलो. Cool, guys. Satyam, it is always like anode as oxidation, cathode as reduction. Sorry to start. अरे नहीं यार उमा. In whole electrochemistry chapter. Is it always? हाँ beta, I mean, whatever NCERT asks you to ask us to understand, we have to. Chalo. So, Uma Dinesh. Nahin, yaar, that is good. Chalo. Gurugram में किसी को अच्छा peer to peer doubt solving is happening. So, Himanshu, Mishra ji, best of luck. Keep on peer to peer doubt solving. But Mishra ji, at least read something. Some, eh? Some. Chalo. I hope everybody have got that what is happening at anode. Now let us go to cathode. Okay, master. So at cathode. Master, at cathode. हाँ, sir. Sir, cathode reduction will take place, sir. Negatively charged now. Negatively charged electrode. Who is positive? Sir, copper plus 2 will also come. It will say, I will give an electron and form copper solid because ions are always in liquid. Sir, water will also come. Water will say, hey, my hydrogen will take electron, give my hydrogen electron, and I'll form OH minus. So you can balance, but I hope I can see the two competition. Now, who is going to win? Who is going to win? Now, for this, you will be needing common sense. What common sense? Sir, we have learned the value of reduction potential of water. Sir, we have learned the value of reduction potential of water. Reduction potential of water was minus 0.83 volt, and sir, we have seen in the previous first part of electrochemistry, let me help you with this, that for hydrogen reduction potential is 0. And after hydrogen, what metals you have which are even less reactive metal than hydrogen? Sir, chap. I hope everybody remember chap. The keyword to learn this. What is chap? C stands for copper, H stands for mercury, then silver, then gold, and then platinum. These are the metals which are even less reactive than hydrogen. So that means, sir, their electrode potential is more. In fact, their reduction potential is, in fact, their value of reduction potential is in fact positive. Are leave learning the value master. Who is having more reduction potential? Copper. Now this is also an application of electrochemistry. Why? Let's say you have extracted metal from a factory, copper. But sir, copper now is having impurity. No issues. Just make that copper as anode. Only copper will go into solution, and the same copper will come and get deposited at cathode. Whatever impurities you have in the anode will remain as it is, and in fact they are dropped down because they are solid impurities as anode mud. And this is how you refine copper. So this is nothing but refining of copper, the common sense behind refining of copper, a direct outcome of electrochemistry, although common sense is used in metallurgy. Yes, not there for JEE main syllabus, but obviously valid for JEE advanced. Hello. Chalo. I hope everybody got this. Now let us move to, although we have some more cases, but yes, let us be time efficient and let us move to, after the qualitative analysis as in what is produced, now let us directly move to the quantitative analysis as in how much is produced. So in order to learn quantitative analysis, that is how much is produced, the first law, acha, this is 9 na, we started at 7. Acha, so we are left with quantitative and Faraday's law of electrolysis, and then the conductivities and the conduction. So we will take another 1 hour, maybe 1.5 hours. So I hope everybody is doing great, everybody is doing good, but let us take 10 minutes of break and then we'll meet because we need to finish this. So this is, I guess, 9. So let us meet at 9:10 p.m. So all those students who are there with me, let us take a 10 minutes break and we will reunite and we will start from the qualitative analysis. Cool. Chalo. Yes, guys. So I have changed my mic because I guess it will be getting out of battery, and I am back. Everybody, just give me a confirmation who is there with me in this session for electrochemistry, where we are now going to start. Where, yes, uh, Rajiv Kulkarni. Hi guys, anyone from Arjuna here? Yes, beta. There will be few, but yes, because we took a break, so I guess few people also have gone for that bio break. Chalo, everybody, let's begin. Let's continue. Chalo, now, sir, sir. What are we trying to do over here, sir? Qualitative analysis, because what is produced is qualitative analysis we have done. Now how much is produced is the quantitative analysis. So who does that quantitative analysis for us? Quantitative, as in what quantity of the products has been produced, either liberated or deposited at respective electrodes. So what are the quantities is the quantitative analysis. Now I hope everybody, I am clearly visible and audible. Whoever is there with me, just give me a confirmation that my voice is visible, because yes, video I can definitely see, but audio I can't hear. So anybody, just give me a confirmation. Rajiv, Kuldeep, Himanshu has gone. Chalo. So I hope I'm audible, guys. Shall we continue? I am audible. Chalo. Then let us proceed forward. Sir, that clearly mean the first law that is going to educate us that how much amount is produced at the respective electrodes is the first law of Faraday's first Faraday's first law of electrolysis, because we are doing electrolysis, master. So we will be getting those amount of some electrolyte getting deposited, or amount of some electrolyte getting liberated. Acha. Then, sir, technically the first law is very simple. It just says that the amount of electrolyte produced, the weight of electrolyte produced, is directly proportional to the charge that is flowing. To what? So through that electrolytic cell that we are using, because obviously using the battery, I am supplying some current, and that current must have flown for some time t, and that will give me the total charge that has been passed, because the charge that has been passed will make the amount of solute deposited at that particular electrode. Sir, can we have the proportionality constant? Yes, definitely, because that is proportional. So the proportionality constant is termed as electrochemical equivalent of the cell, written as a capital Z. This is nothing but electrochemical equivalent of the cell. And how can you write this charge? Array master, charge is Q, and charge is nothing but current into the time for which it has flown. Obviously the unit of current will be amperes, the SI unit for time is second, the SI unit for charge is coulomb. Now master, the only thing, what weight I'm going to get, sir? You will be getting weight in gram, because now we are defining the constant, and that constant is Z. So master, what is the Z? Beta, this Z is nothing but it is ratio of E by F. What is F, sir? F is the charge carried by 1 mole of electron, which is nothing but approximately equal to 96500 coulomb. Exactly, it is 98487. And master, what is this E? This E is equivalent weight of the substance that has been deposited. And sir, we know this equivalent weight is nothing but the molecular weight or molecular mass upon valency factor. So how you can solve this valency factor? Array beta, the number of electron that it has taken, like for copper plus 2, it will be 2 electrons, it will be taking aluminium plus 3 will be taking 3 electrons. And so this molecular weight, definitely I will put in gram. That means I'll be talking of its molar mass, and molar mass is always in gram, and therefore this weight will also come in gram. I hope everybody is clear. This is Faraday's first law of electrolysis. Acha master. Then what about the, yes, we have, let us solve this question. Everybody, let us solve this question so that we can at least do a bit of practice for Faraday's law as well. Yes, giving 1 minute for this, but everybody at least attempt. At least read the question properly. Guys, at least read the question properly. Everybody, at least read the question properly. Chalo, done? At least I hope people, you have read the question. So all those who have read, great. Now let us try to solve. Now the question says, I have 5 liter of 0.4 molar magnesium nitrate. Acha master, this is my electrolyte. It is electrolyzed using an inert electrode. That means, sir, for Faraday's question also, for amount of electricity also, first you have to know what is produced. Acha. Then the question is telling you that using inert electrode, I am passing 3.25 amperes of current. So current I know, and the efficiency is 90%. Sir, how to use this efficiency? Common sense. We'll just check. And I am passing this for 8 hours. So theoretically and actual. So theoretically, what weight I should get? W theoretical. As in, you are passing this much of current, and you're passing this much of current for how much time? For this much time. So theoretically, as in, if efficiency is 100%, I will be getting this much of weight. But beta, if efficiency is not, sir, because practically we know there may be many losses. And if actually something is happening, then the actual weight will be different, sir. And if you multiply this by 100, it will give you nothing but the efficiency, master. And this efficiency in this question is given as 90. That means, master, this is nothing but 9 by 10. Okay. So beta, actually, that efficiency is given to us. Now, sir, we have to give the concentration of magnesium nitrate left. How much concentration is left? Okay, sir. So now if we know about efficiency also, sir, let us first check. Let us first check what was there. Sir, here concentration was 0.4 molar of this magnesium nitrate. After electrolysis, what is happening? Let us check, sir. Magnesium, and obviously it is asking us the amount that is left. So, sir, magnesium plus 2 will be doing what? Magnesium plus 2 will be doing what, sir? It will be going, it is a positively charged species, sir. So it will be trying to get reduced at cathode. Acha. So magnesium can ask for electron and can ask, hey, let me undergo reduction. Magnesium can ask, hey, let me go reduction. But sir, there will be competition because this is aqueous solution. So water will also compete. Water will say, nahi, hut, I will take electron. Who will take electron? Sir, H plus, and it will form hydrogen gas. And sir, it will create OH minus ion. Agreed, sir. But sir, again, electrochemical series of our previous part discussion. But sir, here also you can, without even learning the value, you can predict. Although I have given you this value for water. This is the reduction potential of water, and this value is minus 0.83. And sir, we have even remembered the rhyme, but common sense will also tell you, sir, magnesium is an alkaline earth metal, group 2 metal. It is a reactive metal, sir. Metal will give electron. Why the hell it will take electron? Yes, I'm not saying it will have a tendency, but that value will be less. So who will win? Arey master, water will win. It will lose. So if it is losing, will its concentration be bothered? No, sir. Magnesium is initially also +2. Now also it is +2. But sir, what about nitrate ion? Similar logic. What about nitrate ion? Because it can participate at anode. Similar logic. Why similar logic? Because sir, nitrate ion is NO3 minus. Sir, here also in sulfate ion you have given us a common sense. Now sulfur was in +6 oxidation state. Here nitrogen also it is in its maximum oxidation state. Nitrate ion also will lose the battle for getting oxidized, and rather than sir, how current is passing, who the hell is getting produced at the electrodes? At cathode, hydrogen gas is created. At anode, array master, competition na, water will win. Water can also give electron. Who will give electron? Sir, oxygen. So it will form oxygen gas, give electron, and oxygen gas is gone, sir. So water solution will become acidic. So oxygen gas is produced at anode, and hydrogen gas is produced as cathode. That means, yes, in many questions, this efficiency thing will help you. So we have learned efficiency also. But sir, here, because they are not even participating, that means the concentration will remain as it is, because it is not even participating in the electrolysis. I hope they are just acting as spectator ions. Or beautiful question. A good question, a good logic. I hope everybody is good. I hope everybody is good. So, chalo. So this is the first law of Faraday's first law. Now, what about Faraday's second law? Now, this is also very common sense. See, if I have multiple electrolytic cells connected in series, then everybody will have same charge. So if same charge is flown through them, then the weight of electrolytes that is deposited is proportional to their equivalent weight. Is proportional to their equivalent weight. Whatever weight of electrolyte will be created in whatever set of electrolytic cell, if same charge is passing through another electrolytic cell, because they are connected in series, so charge will be same. You have switched on the battery for time, let's say 5 seconds. So every electrolytic cell will get the same charge. Then the amount deposited, sir, amount deposited will be proportional to the equivalent weight of me as a electrolyte. Sir, but how to use this? Definitely, beta, these questions come in exam like anything. So a JEE Mains question, let us attempt this quickly. Integer type question. So at least read, beta. At least try and read. Poll is not coming. It's okay, beta. Hit the comment section with answers. But yes, definitely, because without question, nothing is productive. So I am at least giving time to people to read at least the question. Everybody. Chalo. I hope people are reading. Never give up. Great name. Chalo. Let us see. Acha. The question says the mass of silver. So silver displaced by quantity of electricity. Okay, sir. So at one electrode, I may be having silver getting deposited. I know how silver will get deposited. Sir, silver will take one electron and will form Ag solid, and silver solid will be getting deposited. Okay, at in any electrolytic cell. which displaces this much ml of oxygen at STP. Acha. So mass of silver that is deposited. How silver will be deposited? Because charge must have flown through some electrolytic cell. The same amount of charge should displace what? Sir, the same amount of charge should be going in somewhere else, some other electrolytic cell, which should create oxygen gas. Acha, master, you are talking of oxygen gas creation. Who will create that oxygen gas, master? Water. So the same charge must be flowing to water, and water must be forming oxygen gas. Hello? Sir, if water forms oxygen gas, then one oxygen gas is created by how many electrons? That will be the valency factor for oxygen. Acha. So, sir, here na oxygen is 2, so I will write 2 here, sir. But if oxygen is gone, sir, then solution will become acidic, sir. And in order to balance hydrogen, sir, I need 4 hydrogen, sir. And therefore, sir, 4 electrons will be required. Acha. So, valency factor will be 4. Valency factor for one silver, because this is getting deposited and this gas is getting liberated. So these are the product of electrolysis. Acha. Sir, maybe in some electrode or different, because actually this is reduction and this is oxidation. So it may happen in the same electrode also, in the same electrolytic cell also. Ultimately charge is same. And what I said, sir, if charge is same, then the weight deposited will be proportional to their equivalent weight. So because charge is same, so weight of silver deposited upon weight of oxygen gas liberated will be equal to equivalent weight of silver upon equivalent weight of oxygen gas. But sir, here weight is not given. For oxygen, what is given? Sir, for oxygen, volume is given. Sir, but we know from our common sense of number of moles, sir, number of moles is equal to weight of substance upon molar mass. Sir, it is also equal to volume occupied by gas in liters upon 22.4. But if, because I guess over there it is given in ml, so let me write in ml only. Sir, volume I know, sir. So if you know volume, how much volume you know? Sir, then weight of oxygen gas will be, volume is how much? Sir, 5600 upon 22400. And sir, what is molar mass of oxygen? Array yaar, 16 into 2, that is 32. I hope everybody get it. Acha. So that means, master, now I know this thing. Okay, sir, this thing is clear, sir. What will be equivalent weight of oxygen? Sir, equivalent weight of oxygen will be molar mass of oxygen, which is 32, upon valency factor, sir, which is 4. What will be equivalent weight of silver? Sir, equivalent weight of silver will be molar mass of silver, which is 108, as in mass of 1 mole species silver, atomic mass in gram, upon valency factor is 1. Sir, RHS also I know, this LHS also I know. What I need mass of silver. Array, sir, this you need and this you can now solve, because this is the only variable. Hello. Now let us directly put this value. I guess everybody can see this is 4 times, because 5 4 are 20, 600 2 times is 2400 rupees. And actually that means this is nothing but 32 by 4. So because that is also 32 by 4, so this is also 32 by 4, so it is cancelled. That means weight of silver is directly 108. So no calculation also you have to do. So answer is definitely 108 gram. I hope everybody is clear, guys. So answer is definitely what? Sir, integer type. I hope I've given, sir, 108. Chalo, never give up. Great. You are not giving up. Sir, they are bothering us. No, baby, I can definitely see some people are here peer-to-peer doubt solving. It's okay na. Beta, when you will be giving your paper, I can definitely ask my YT team to just remove people. But beta, in fact, once you will be giving your actual JEE paper, maybe the person sitting next to you will be not that serious. Will you ask that person to leave? No, beta, that's his democratic right. He has also given the fees for the exam, so he will. So can we make surroundings comfortable for us? Can we make ourselves focused enough? How to practice? So practice here. Practice this also, that you have to say, in exam, in JEE paper beta, what is the main thing that you have to do? Select questions, because the noisy questions will be asking you, hey, come to me, attempt me, but don't attempt them. Attempt easy and moderate first. Who is going to teach you that? Obviously, your selectivity, your practice of the question. But sir, practice in a chaos. If that is bothering you to an extent that you are feeling, sir, I'm getting disturbed, that means that that's a chaos for you. And if you're practicing to work in this chaos, then obviously, I hope everybody can get it. Hana? I mean, just giving you an analogy, and yes, you will also motivate other by giving answers. You will motivate other people, or you're that guy studying. So they will also, the compassion also, maybe because of you, they will also start solving 1-2 questions. Hana? Chalo. Cool. Now, master, this much we have done. Now let us go to the last topic. Now, master, let us go to the last topic. Now, last topic is nothing but, sir, electrolytic conductance, because, sir, we know the solution, we know the metals that we have with us. Metals are conducting because of free moving electrons. But, sir, that electrolytic solution is conducting because movement of ions, master. And who will govern the movement of ions? Sir, the movement of ions are governed by certain set of principles. Definitely yes. Sir, if ions are attracting each other, they will feel resistance. If ions are attracting each other, they will feel the resistance. And if, sir, they have large volume to move and there are sufficient number of ions, then they will just roam around, because they are hydrated in water and their hydrated size is small. Hydrated size is small, so they can easily conduct. Now remember one thing, sir, what is decided, who decides? So more will be their conductance, more will be their conducting in solution. So let us now conceptualize. We definitely know resistance is how you define resistance for your metallic conductors, sir. It is equal to potential. It is obviously a constant, the ratio of potential upon charge that you are flowing, current that you are flowing. And reciprocal of this resistance is conductance. What is unit of resistance for us, sir? Ohm. What is unit of this conductance, which we will now mention as G? Obviously, sir, this is inverse of resistance. So this is ohm inverse. Some people even write it as MHO as an inverse. So mho, but yes, the more famous unit is Siemens. Acha, with a capital S. Now, okay, master, this much is done. But master, let us conceptualize this quickly. So let me just borrow this slide and let us conceptualize everything in a single slide. Acha, master. So one thing we are very clear, master. More be the resistance, more be the, so talking about conductance. So one thing we are clear, very, very comfortable with, master, is, sir, resistance of the electrolytes is due to what? Beta, it is due to attraction force. It is due to attraction between ions. So how you can decrease this resistance? So point number 2, their conductance will increase if they have enough volume, as in dilution. So if you have available space, as in if your solution is dilute, then the ions, the hell, they can move properly. If they can move properly, they are not meeting the opposite ion, the plus minus. If plus will meet minus, they will attract, so resistance will happen. So actually concentration, if you increase concentration. So point number 3, which is I guess more important, sir, if you increase concentration, what concentration term is famous for us everywhere, sir? Molarity. So if you increase concentration, sir, attraction will increase. And sir, if attraction is increasing, then resistance will increase. And sir, if resistance is increasing, that means, master, conductance will decrease. Acha. So we feel you add ions, so they will conduct. Arey, nahi, you add, if you increase more ions, they will start attracting each other. If you want them to freely move, you make the solution dilute. You add ions, but give them space. How you will give them space? You will have to increase the volume of solvent. So conductance will be directly proportional to dilution, which is increasing volume, because sir, molarity is moles of electrolyte upon volume. So you increase volume. Hello. Acha. This is an important point that you should know now. Whose conductance will be more? Who can run faster? Who can run faster? I can run faster because I am the slimmest over here. You people are fat enough. You can't travel. You can't run. I mean, just analogy. And sir, that means, if, let's say, if I have Li plus, or let's say I have Al plus 3. So technically, sir, which ion will be heavily hydrated? Beta, this is decided by their hydration enthalpy. And hydration enthalpy depends first upon the charge, because the most dominating factor is charge. Yes, if charge is the same, then you do the size comparison, but first priority is charge. So among them, who will be heavily hydrated? Aluminium. Sir, if aluminium is heavily hydrated, because sir, its charge is more, that means it will be crowded and surrounded by water. So if aluminium ion is surrounded more by water, then beta, you tell me what will be its conductance? Sir, first of all, if charge is more, I will be attracted more to the electrodes. Why the hell I'm moving? Under the influence of electric field. So ultimately, the property is dominated by the property of charge. So whenever charge is different, you should never see the size, because that is a dominating factor. So whose hydration will be more? Sir, aluminium plus 3 hydration will also be more, but the more it is hydrated, I do not care, sir, although it will be surrounded by water, but sir, it will have more conductance, because the movement is because of the application of charges. Hello. Yes. Now if charge is same, now this is good beta, fifth point. If charge is same, now you tell me, among Li plus and Cs plus, this is order of conductance, this is order of G, which will be proportional to charge. But if charge is same, then who will conduct? Now it will be depending upon the hydration enthalpy. Because hydration enthalpy, if charge is same, then it will be decided by size. So if size is less, then my hydration is large. That means lithium is heavily hydrated. What does heavy hydration mean? Sir, heavy hydration mean that it is surrounded by water like anything. So lithium plus is surrounded by water, then how the hell it can move? Because it is bulky now. Li plus in gaseous state is small, but sir, in aqueous state it is bulky, it is heavily hydrated. And a bulky species can't move, because both of them are attracted with the same amount of K, Q1, Q2. Electrostatic force of attraction is obviously K, Q1, Q2 by R square. Set distance, obviously if I'm running distance, so sir, it is product of charge. So obviously who will be attracted more? Who will have more charge? But sir, once charge is same, it will be decided by your hydration. So who is heavily hydrated? Small ion in gaseous state. So in water, the small ion will be bigger, heavily hydrated. So who will have more conductance? Again, G. So again, this is order of conductance. I hope everybody is clear. I hope everybody is clear. Upamanyu is saying, sir, can you repeat, please, that part? Again, Upamanyu, I'm repeating. I hope, what is the resistance between electrolytes? Sir, plus minus attraction. So the more concentration you have, the more moles of electrolyte you will have. Electrolyte will give plus also, minus also. But once plus minus will move, they will attract, and attract will give resistance. So why the electrolytic solution have resistance? Because of attraction between plus minus. And sir, if volume is large, I have ions, but I have given them available sufficient volume to move, to roam around, sir. They will be happy, they will move, and hence conductance will increase when dilution will increase. Hence, this is the common sense for conductance G. Among, if you are having multiple ions, then first is obviously property of charge. So more be the charge, more will be the attraction, because Coulombic force of attraction, I am moving because of the supply of field, electric field, plus minus, the battery. So under the influence of electric field, who will move more? Who is having more charge? So first of all, whoever is having more charge, I will not bother to see the size. But yes, if charge is same, then I'll bother to see the size. Who will be heavy will move slow. So ion in gaseous state, who is smaller in gaseous state, will be bigger in water, because hydration is inversely proportional to size. That means in water, cesium plus is smaller, less hydrated, and hence it can move freely because it is not crowded by water. Cool. Dr. Mehak, Bisma, Pranav, Upamanyu. Chalo. I hope everybody is clear till here. Now, sir, next common sense. So after this beta, the next common sense point, I am just discussing points here because it will help you like anything. And it will be precise also. So point number 6. Now the next thing that you need to know is, as you increase temperature for those electrolytic, for those metallic conductors, sir, with increase in temperature, resistance increases. Because for them, we know there is R is equal to R naught into 1 plus alpha delta T, that coefficient of expansion, but that is for metallic conductors. Come here for electrolytic conductors. Sir, for electrolytic conductors, if you increase temperature, my kinetic energy as an ion will increase and I will conduct more. So for electrolytic conductors, if you increase temperature, their G will increase. For metallic conductors, their resistance increases, G decreases. So again, a very beautiful point of difference. Now, sir, at least define this conductance for us, sir. So beta, technically, we know what conductance is. Sir, resistance formula will know it is equal to rho L by A. Everybody know this. And sir, let's say if this is my electrolytic cell, which I am trying to connect with any battery. But sir, who will conduct? Beta, I will be putting, first I will be putting water, because ions will be there in aqueous medium, and then I will be putting ions over here. Sir, A plus ion, B minus ion. So I have used an electrolyte which is conducting. Okay, sir. So the resistance that they offer can be calculated. Acha, sir. Good. So what is this L? This L will be the length of this electrolytic cell. What is A? Sir, A will be the cross-sectional area. Acha, let me take cation as X plus, anion as Y minus, because A I am taking as cross-sectional area. So, sir, A will be my area of cross-section. I hope everybody know this. Acha, sir. Beta, technically, these conductivity cells that you take, they are not very large. So generally, the unit given is in centimeter. So here I am, although SI unit of length is meter, but in chemistry, whenever you will be thrown questions around it, you will be seeing centimeters. So let's say if length is 1 centimeter and this is area is 1 centimeter square, that means this complete volume is just 1 cubic centimeter, 1 cc. So for this 1 cc of electrolytic cell, R will be equal to rho. Hence you can calculate rho. What is rho? Sir, this is resistance and this is specific resistance. Yes, sir. Specific resistance is also called resistivity. And sir, if you just because sir, I can change different electrolytes, sir. But technically, if I have just I have just constructed an electrolytic cell, then for this electrolytic cell, I also define cell constant. So what is cell constant of electrolytic cell? We represent this as G stick, and this is nothing but the ratio of L by A. So the next form that becomes, sir, because we know G is nothing but 1 upon R we have just seen is nothing but rho, or rather this I'm writing as G stick. So rho into G stick 1 upon R. And sir, technically we don't write, whenever we write G, we don't write rho. So 1 upon rho is also termed as K, which is also called kappa. This kappa is also a constant, and this constant is nothing but, like rho is specific resistance, so this is specific conductance. Conductance. Simply it is called conductivity. I hope everybody is comfortable. Cool, sir. Now, sir, that means if this is K, then I can formulate a very beautiful formula, which I am definitely suggesting everybody should remember. So if this is K, then sir, K is nothing but it is G into G stick. Acha, sir. That means this K is nothing but G into G stick. Point number 1. Okay, sir. I got it. G stick is cell constant and this is G. Sir, but whatever concentration of electrolytes we'll be using in our chemistry, we will be focused on their concentration. So if I change those concentration, let us formulate this conductance in terms of the concentration also that we are taking. Yes. And hence for the next point, I am defining their molar conductance. Sir, what is molar conductance? The definition is pretty simple and but yes, conceptually it is great. Now, obviously you know you need electrodes to conduct electricity. I will connect these electrodes with battery. But now this is my electrolytic cell. How I am defining molar conductance? I am just keeping the distance between electrodes as 1 centimeter. Let us consider this is my electrolytic cell, and this electrolytic cell that I am taking, this is my electrolytic cell, and this electrolytic cell that I am taking, the distance between the electrodes, let's say it is 1 centimeter. Why? Because if I add electrolyte, sir, they will start getting attracted. So how we have defined it conceptually, this molar conductance, which is represented as lambda m. So how we are defining this molar conductance, that first of all, in order to make these ions conducting, I need water. But at least I need minimum amount of electrolytes so that they can conduct and show me some substantial value. So I am fixing in this water, I am fixing the electrolytes that are added is 1 mole. So if I'm adding 1 mole of electrolyte, let's say my electrolyte is AXBY. So here I will be having A plus Y cation and B minus X anion. Cool. So how much electrolyte I have added? 1 mole. Sir, if electrolytes that you have added is 1 mole, then what will be the molarity? Molarity is number of moles of solute, 1 mole. But sir, if 1 mole is a very large value, no. Large value, but now you allow them infinite space. As in, sir, you take the cross-sectional area so large, that they have pretty decent available volume. So I'm using 1 mole of electrolyte, and I'm making the area of cross section so large that they have easy availability of volume. So dilution, I'm not saying volume is V, because I'm giving sufficient space, I'm giving them sufficient space to just roam around. Hence, I'm saying I'm adding 1 mole of AXBY in a large volume. And this large volume is also technically termed as dilution, at a dilution of V. At a dilution of V. But sir, technically this volume V is a large diluted volume. I hope everybody is clear. I hope everybody is clear, guys. I hope everybody is clear. Acha. Now, let's say if, sir, because you say cc, cubic centimeter. So, sir, 1 cc is 1 ml. Sir, 1 cubic centimeter is 1 ml. So, let's say this volume also I'm taking in ml. So, is VML is the volume for large volume. So, how you can define molarity? Sir, molarity is equal to number of moles upon volume of solution in liters. But because you are mentioning it in ml, so I will have 1000 in the numerator. Defined. Okay, sir. Now you tell me, have we decided what is conductance of 1 cc? Haan, sir. Let us revise this, sir. We have just considered here, sir. If this is 1, R is rho. So, beta, if this is 1, G is K. If both is 1, then G asterisk will be 1. So, for that 1 cubic centimeter, G is nothing but K. So, if I have 1 cc, of electrolytic cell, then what is its conductance? Sir, for 1 cc, conductance is K. So for 1 cc, I hope everybody is remembering, I hope everybody is getting it. It's beautifully important. Sir, for 1 cc of electrolytic solution, G is nothing but K, but this is for 1 cc. So for VCC it will be, sir, for VCC, for complete V cubic centimeter of electrolytic solution, the conductance is, first of all, it is called molar conductance. Why? Sir, molar na? Because this is conductance of how much of electrolyte? 1 mole of electrolyte. So the conductance, sir, what is molar volume? Volume of 1 mole substance. What is molar mass? Mass of 1 mole of mass. Mass of 1 mole of substance. Sir, what will be molar conductance? Conductance of 1 mole of electrolyte. But sir, if you take very large electrolyte, they will attract. No. Give them available volume. Dilute them. So conductance of 1 cc is G. But sir, conductance of 1 mole of electrolyte dissolved in a diluted solution having dilution V is defined as molar conductance. So this molar conductance will be, sir, for 1 cc. Now I'm not focusing on this because I have got a specific version of G. So I'm not focused on G now. Yes. For 1 cc it is K. So for 2 cc it will be 2K. For 3 cc it will be 3K. For VCC it will be KV. Kendriya Vidyalaya. Hello. Sir, now just put V na. So what is V? So I have formulated a formula for lambda m, that means. So this lambda m is nothing but K, and instead of V master, where is V? Different pen master. In terms of V, sir, V can be written as CC or ML is same. That's why CCML I used. CCML is same. So this V can be written as a 1000 by M. So this will be 1000 upon molarity. Acha master, we have got formula. Yes. And sir, we are very free. Sir, I can use molarity in my basic unit, moles per liter. I do not care because volume I have converted. So this is in liter only. Yes, sir. But sir, what will be unit of K? Sir, it will be depending upon lambda m. Acha. Sir, unit of K will be, array sir, let us see where I have, we have defined K. Master, where is K? Ha, sir, here K. So sir, unit of G, and what is G asterisk? Sir, G asterisk is centimeter upon centimeter square. So this unit of K is Siemens per centimeter. So unit of K is, so unit of K will be, let us write unit, beta unit is very important. So this is Siemens per centimeter. And what will be this? Sir, this is lambda m. So Siemens, sir, that unit, this is, because you can think of this centimeter cube also as volume. So per centimeter and centimeter cube. So this will be Siemens centimeter square per mole. I hope everybody is getting it. Siemens centimeter square per mole. I hope everybody is getting it. Hello. Hello. Yes. Hello. Acha. So everybody, let us put these things perfectly. Now, sir, if we have defined, see, you can watch all these theoretical explanations also, but yes, I want everybody to quickly move to questions. So after this, let us now attempt a basic question for calculations. Yes, everybody attempt this, giving you 1 minute for this. Then we'll directly move to Kohlrash's law. But yes, at least attempt one question. Quick, everyone. Quick, everyone. Chalo bhai. I hope people. Chalo. So the question says, the molar conductivity of 0.25 molar solution of KCl at some temperature is this. So we look at the unit beta because unit is important. Acha. So sir, if this is, else sir, if it is not given, then convert. Else it is not given, then convert. Okay sir. So sir, this is molarity sir, and conductivity Siemens, this is kappa value sir. And molar conductance, as in sir, you are supposed to calculate lambda m. So lambda m will be K into 1000 upon molarity. We are free to use these units, and then I will get this as Siemens centimeter square per mole. So value of K will be how much? Sir, K is given as 0.0275 into 1000 rupees, sir, upon molarity, which is 1 by 4, sir. So this is 1 by 4, so 4 will come in the, because 0.25 is 25 by 100, so 1 by 4. So I hope now this is, I mean, obviously you have to solve, and once you solve, you will get 3 as your answer. And yes, beta, these types of questions are also logically very famous, very easy, but yes, you should know them by heart. Now, sir, how can you determine? Obviously, you define equivalent conductance also. Obviously, देने के लिए तो chat open कर सकते हो. Okay, चलो. Now, everybody. Oh, come on. Chalo, everybody. Yes, Upamanyu, great. Now, everybody. After this, what you should know is you can define equivalent conductivity also. What is equivalent conductivity? Sir, equivalent conductivity is just like molar conductivity. If you have 1 gram equivalent of electrolyte, so lambda EQ will be equal to K into 1000, but sir, denominator will have normality. So yes, That lambda equivalent is less asked, but yes, you should know it because we have to finish and deal with the complete thing. So I'm just moving to the more important area, which is determination of molar conductance. How you determine this molar conductance in actual practice? It is determined experimentally, and this Debye-Huckel-on-Sanger equation is the statistical outcome, which says, definitely sir, this much we have seen. What? That sir, G, conductance, molar conductance, equivalent conductance, all these conductance, sir, they will increase once dilution will increase. Yes, there is only one conductance, that is K. For K, one should always remember, K increases when concentration increases, because K is conductance of that 1 cc. This 1 cc volume will only get ions once you add more ions. Yes, sir. But overall, it will create a resistance. But, sir, for 1 cc, I am only bothered. Who is only bothered with that 1 cc volume? K. So, the first logic that I want to give here only is G, lambda M, and lambda EQ. All of them increase when dilution increase. In fact, they decrease with increase of concentration, the molarity. But there is only one person who is very selfish, which is K, because K will only increase when concentration, as in molarity, will increase. Why? Because that 1 cc will only get ions once you add more number of solutes. I hope you get it now. How to determine this? Sir, obviously this we have seen. So we have a curve between molar conductance and under root of molarity, as in concentration. Because NCERT in this chapter represent molarity as C. Hence I am writing C also. So if you plot a graph between molar conductance and under root of C, array again master, if you increase concentration, then sir, all the conductance will fall. So yes, it is falling. Sir, it is falling for weak electrolyte also, it is falling for strong electrolyte also. But sir, I can definitely see this, that for strong electrolytes, that's a straight line. And sir, because that's a straight line, so sir, this is with under root of concentration. So equation of straight line can be determined, sir, and that equation is called Debye-Huckel-on-Sanger equation. You do not have to learn the name of the scientist, but yes, please learn the equation, very famous. So this says lambda m is equal to lambda m naught or lambda m infinity. Whenever under root C becomes 0, obviously I can extrapolate this and I can definitely calculate this value of lambda m naught, because people write it as naught also and infinity also. Why? Because this is 0 concentration, but sir, when concentration will be 0, dilution is infinite, because sir, molarity is equal to, sir, we know molarity, which is concentration, is, if number of moles, let's say, is constant, it's volume. Sir, if concentration is 0, then 1 by 0, that means volume is infinitely large. Array, you do not put 0 electrolytes, you just put some electrolytes, but you increase the volume so that moles per unit volume denominator will increase, so concentration will approach 0, because ultimately even without ions you cannot make the solution conducting, so you need ions. But sir, practically the 0 value, how I can calculate? No, practically you cannot calculate. You calculate, let's say, at this point and at this point. These 2 points you can calculate. Any 2 points you can calculate, because correspondingly you can put some concentration for strong electrolyte and then draw a straight line. So wherever it is cutting the y-axis, you can experimentally calculate the value of limiting. This lambda m naught or infinity is called limiting molar conductivity at 0 concentration or at infinite dilution. Both are one and the same synonyms for the same intercept, which you can calculate using experiment for a strong electrolyte. But sir, obviously for weak electrolyte also, sir, it is increasing. But sir, it is increasing infinitely, because equilibrium chapter, according to Ostwald dilution law, even weak electrolyte can act as strong electrolyte. How? If you increase dilution infinitely. So sir, at zero concentration, dilution is infinite, and weak electrolyte is also conducting like anything, so its concentration is approaching infinitely large value. But sir, for weak electrolyte, I am very sure I am unable, for this weak electrolyte, for all the weak electrolytes, it will be a curve. It will not be a straight line. Sir, then how you can find the limiting value? No, that was a problem. That you cannot find the value for the limiting molar conductivity of these weak electrolytes. And in order to overcome this, this law came into picture, which is loved by JEE Main JEE Advanced like anything. And this law simply tells us, which is called as Kohlrash's law, that do not bother. It says you do not worry. It says you do not worry. Why? Because the equivalent conductivity or the molar conductivity not normal at infinite dilution or zero concentration, that infinite value is equal to summation of infinite limiting conductivities of the constituent ions. Equivalent conductivity also, molar also. But yes sir, if you will take molar, then you have to multiply with the stoichiometry. Equivalent, so normality has valency factor in itself, so you do not have to bother. You just add their equivalent conductivity of cations and anions. This is nothing but Kohlrash's law. And what is this application of Kohlrash's law? Sir, for strong electrolyte, lambda m also and EQ also I can calculate experimentally. But using that, I can calculate for weak electrolyte also, because for weak electrolyte also their limiting value will be equal to their cations and anion summation. I didn't get it, sir. A very beautiful application which of Kohlrash's law. Now let us do that application. So the limiting molar conductivity of ammonium hydroxide you have to calculate. Sir, this is a weak base. Sir, this is a weak base. So sir, I cannot find it experimentally. No issues. Use Kohlrash's law. Kohlrash's law says that limiting molar conductivity of ammonium hydroxide will be equal to what? Sir, it will be equal to limiting molar conductivity of ammonium ion plus limiting molar conductivity of hydroxide ion, because both ions are 1 1, so here I do not even bother. Yes, if it is different, then I have to multiply with the stoichiometric coefficient. Okay sir, experimentally I cannot find this value, but according to Kohlrash's law, I know this LHS equal to RHS, so I need to just create this equation. How can I create this equation? Let us check. Now sir, this will give ammonium and chloride. Sir, this will give ammonium cation and chloride cation. So I'm just using Kohlrash's law for each, because for, sir, can ammonium chloride lambda m naught can be calculated? Yes sir, because salt is always a strong electrolyte. So it can be calculated experimentally, and such NaOH is a strong base. So for all of them, these values can be experimentally calculated. But now apply Kohlrash's law in them. So ammonium and chlorine, sodium cation and chlorine anion. Sir, this is sodium cation but hydroxide ion. Acha, sir, then sodium, because this is subtracted, so sodium cancelled, sir. But sir, chlorine is not getting cancelled, so I need to cancel 2. Okay sir, so I need ammonium ion. This is cancelling ammonium, so no. Here chlorine will be added. No sir. So Na plus, no, Na plus will remain. Sir, I guess no. Sir, this will work. Why? Because ammonium cation plus Cl minus, this will be Na plus plus OH minus, and this will be Na plus and Cl minus. But this is with a minus. So this Na plus and this Na plus will be cancelled. This Cl minus and this Cl minus ion will cancel. That means I only have ammonium ion and hydroxide ion. So technically, with fourth equation, I can calculate limiting molar conductivity even for a weak base. So answer will be 4 for this particular case. Yes. I hope everybody got it. Now, what is the second application, sir? What is the second application, sir? So second application, which is probably more crucial, more important, is after calculating the value of limiting molar conductivity even for those weak electrolytes, experimentally how you calculate their degree of dissociation by using again Kohlrash's law. Because ultimately you have calculated the limiting molar conductivity of that weak electrolyte, which otherwise you do not even calculate experimentally. Now, what will be alpha? So, alpha, degree of dissociation for those weak electrolyte, will be nothing but their equivalent conductivity at any concentration C upon that limiting value. Sir, but generally molar concentration is given. So, molar concentration upon limiting molar conductance. This will give you value of alpha. Sir, if I know value of alpha for that weak electrolyte, I can also calculate the dissociation constant, because Ka for a simple weak electrolyte, let's say weak acid Ha, it will be dissociating as Ha plus and A minus. So at equilibrium, it will be C minus C alpha and C alpha. So K will be C alpha square upon 1 minus alpha. Yes. If alpha is less than 5%, you can even do this 1 minus alpha approximately 1. So this K will be simply C alpha square. But yes, please remember this ionic logic. You can only do this approximation when alpha is less than 5%. If not, calculate complete. Hello. 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 I hope everybody, I hope everybody is good. Chalo. Great. Sir, there is one more good type of question with that, which is another application. Actually, advanced started it, but now mains love it like anything. See, the logic says you can also calculate the solubility and KSP of a sparingly soluble salt. How, sir? Because beta, obviously one should know this, a very good common sense and logic, but yes, the statement will help you like anything. Sparingly soluble salt means they are very less soluble. They will dissociate into ions sparingly, very less. And saturated solution of sparingly soluble salt can sir, let's say if in the question it is given a sparingly soluble salt is there, but it is saturated. So what does saturation mean? That whatever is the maximum amount of that sparingly soluble salt you have used has been dissociated. So sir, how come maximum amount be dissociated? By increasing dilution, because we know according to Ostwald dilution law, even a weak electrolyte can be forced to dissociate by making the volume infinitely large with respect to amount used. And sir, if volume is infinite, that means that particular value, that particular condition is the condition for infinite dilution. Then only a weak electrolyte will dissociate. Now this theoretical logic I am using. How? Because technically, sir, molar conductivity lambda m is equal to K into 1000 upon molarity. But sir, for that particular sparingly soluble salt, how much of that sparingly soluble salt is soluble? Let's say its solubility is S, but yes, this will require knowledge of ionic equilibrium. So let's say the ions that it is forming, how you consider that ions, we define their solubility to be S, the equilibrium value. That S can be calculated using their KSP. I hope everybody remember, if I have AXBY, this has nothing to do with electrochemistry, by the way, guys. So if AXBY dissociate and forms A cation and B anion, stoichiometrically it will be X times of A and Y times of B. Sir, if 1 mole dissociate, X and Y is produced. So if S moles, let's say solubility of this sparingly soluble salt is S, saturated solubility. So 1 produces S. So S will produce XS. S is the solubility. Moles per liter. If 1 produces Y, so S will produce YS. What will be equilibrium constant? Sir, for this it will be KSP, because this is also constant, not at all dissociating. It will be concentration of cation raised to the power X as an XS raised to the power X, YS raised to the power Y. So this will be X raised to the power X into Y raised to the power Y into solubility raised to the power X plus Y. This will be your KSP. So if KSP is given, I can calculate S. Hello. For whatever type of ions, accordingly, I will choose X and Y. Sir, but this solubility is its molarity, how much it is getting dissolved. And sir, this Saturation can only be created at infinite value. So, sir, theoretically speaking, this lambda m is not normal lambda m, sir. It is the limiting value. So if I write this lambda m as lambda m naught or infinity, this molarity can be replaced as solubility, and this becomes a very beautiful formula theoretically, conceptually. Hello. Hello. That means that I can even calculate solubility of a sparingly soluble salt if I have lambda m naught for that weak electrolyte, which can only be determined using Kohlrash's law. So again, an application of Kohlrash's law. And beta advanced use it, I don't know, so many times. And obviously mains also do it. Hello. Hello. Yes. So I have titration curve here, beta, but I feel we should do titration curve when, because technically titration is a topic which will be best discussed with equilibrium. Because with equilibrium chapter we discuss these titration curves. So let us leave titration curves over here, because definitely you have to practice questions, because yes, I have taken included so many questions here, so you have to practice those questions. From where, in order to get these lecture notes, go to PWJ English WhatsApp channel. After the live is done, I will put these lecture notes there in WhatsApp channel, so that you can download and you can watch again maybe the videos if you want, or practice those questions. It will help. So this is me, GSA, signing off. I had a good time, but yes, participation was not uh, uh, optimum, but still, I hope my Laksh student will be watching this, because they must be having their class. So they will be watching after the session is done. And I hope you will also be getting benefit out of it. So this is me, GSA, signing off. Everybody take care. I will see you soon. Bye-bye.